Professor Aquil Ahmed, Operations Research, Aligarh Muslim University, Aligarh. Respected Dean, School of Mathematical and Computer, Professor Asif Hussain. Respected Dean, School of Education, Baba Ghulam Shah Badshah University, Professor G.M. Malik. Heads and directors of various departments, my fellow colleagues and all the participants. Assalamu alaikum and a very good afternoon to all of you. I am Dr. Majid Bashir Malik, Head Department of Computer Sciences, Baba Ghulam Shah Badshah University. I welcome you all in this faculty development program, Data Science Applications in Science and Technologies, organized by the Department of Computer Sciences, Baba Ghulam Shah Badshah University. It gives me immense pleasure to present a welcome address of this FDP. We at the Department of Computer Sciences, Baba Ghulam Shah Badshah University have always been thriving to create a niche in this competitive world, and a faculty development program on such a current and demanding topic, that is data science, is just one among such events. We have always been abreast with the Department of Computer Sciences of our sister universities, although the source of inspiration and guidance being the Honorable Vice Chancellor, Professor Akbar Masood, who happens to be the chief patron of this FDP. He has always been instrumental in supporting such events in this university. Under his able guidance and unreplenishable words of wisdom, we have been able to organize a faculty development program on such a relevant topic, that is data science applications. As a matter of fact, data science is an interdisciplinary field of scientific methods, processes, algorithms, and systems to extract knowledge and insights from and apply knowledge.
अभी लेक्चर चल रहा थोड़ा, बल्कि कल आई, आज नहीं। आपके फादर हैं इनके, आप बाहर जाइए।
And apply knowledge and actionable broad range of application domains. Advances and low-cost storage devices, huge toms of data are being created in a 90% of the data that is available these days has been created during the last 2 to 3 years. Every day, the internet users generate nearly 3 quintillion of data on YouTube is being uploaded every minute. 40,000 search queries and 171 million emails per minute. See the volume of data being generated, and these are just few, hundreds of like that. Moreover, almost all the domains in this world contribute to this massive volume of data. The data is heterogeneous and moreover complex too, storing such huge amounts of data, retrieving it when required, processing it as per domain requirements, and obviously generating knowledge out of it, what data science has to do. Even these days, we are talking, and even more to say, generating wisdom out of the vision. There is no domain that is left science. Researchers of the data science have been contributing to name a few like telecommunication industry, bioinformatics, financial data analysis, education, criminal investigation, healthcare, banking, manufacturing, even medical diagnosis also. And it has returned a success in till eternity, and even will continue. The challenges to derive useful nuggets of information from data toms, from huge toms of data. We need to be prepared to accept such challenges and develop solutions. For the matter of making ourselves aware is the first step, followed by getting down to the practically workable solutions for the benefit of the society. So as to eliminate, educate, make the audience or participants aware, and give suggestions and directions, we have with us eminent scholar I'm certainly sure that it will be a treat to listen to them. I would like to urge to all the resource persons by getting actively involved in this FDP. To speak on the topic, we have a list of eminent scholars and researchers who will educate us with their research and knowledge. To start with, today we have with us Professor Aquil Ahmed, Chairman, Department of Statistics and Operation Research, Aligarh Muslim University, Aligarh, who will deliver a talk on data analysis using software package. I'm sure that this is gonna be a very interesting and fruitful talk to all, particularly the researchers. I welcome you, Professor Aquil Ahmed. After lunch, we will be joined by Dr. Surajit Debnath, Head Department of Medical Laboratory Technology, Women's Polytechnic, Tripura. And he will have a talk on the biomedical applications of data science, which will be focusing on vaccine design and cancer diagnostics through Python based on GUI. I welcome you too, sir, if you are there. Later on, tomorrow onwards, we will have with us a list of other eminent scholars. Professor Aman Huda. He will be delivering a talk on analytics-enabled research paper writing. We'll be having with us Mirza Muhammad Sufyan Beg Saab. He is Principal Zakir Hussain College of Engineering and Technology. And moreover, we'll be having Dr. Muhammad Zakwan from Manu. And we'll be having Dr. Muhit Ahmed Bhatt from University of Kashmir. He will be delivering a talk on data science in agriculture. We'll be having Mr. Vinay Kumar Singh, Dr. Shahab Shakib Suhail from Jamia Hamdard. We'll be having Dr. Love Kumar from BITS Pilani, Hyderabad. And we'll be having Professor Mansaf Alam also from Jamia Millia Islamia. I hope and wish that their presence in the program will enlighten all the participants with knowledge and research endeavors for the betterment of the society. And with these words, I would like to sign off and switch. Ms. Najma, may I please switch our. Thank you, Najma.
Thank you so much, sir. Now, I would like to request our chief guest, Professor Iqbal Parvez sir, Dean Academic Affairs, Baba Ghulam Shah Badshah University, Rajouri, to enlighten us with his words. Over to you, sir.
Ms. Najma, I would like to inform you that he is busy somewhere there in preparing that issues regarding the hostels and etc. like that. He will not be able to join. He's very busy right now. I think we should continue with the lecture.
Okay, sir.
Since he is not available.
Without wasting much of time, I would like to request our today's resource person, Professor Aquil Ahmed. But before calling him, let's have a quick look over his biography. Professor Ahmed is the chairman, Department of Statistics and Operations Research, AMU Aligarh. Professor Ahmed did his MSc and MPhil from AMU Aligarh and PhD from the University of Roorkee, presently Indian Institute of Technology, Roorkee. He has served the Department of Statistics, the University of Kashmir from March 1988 to April 2014. Professor Ahmed is the founder, Head Department of Statistics, University of Kashmir, Srinagar. He has also served as a professor of statistics at the Qasim University, Saudi Arabia for 2.5 years from December 2008 to June 2011. He has guided 16 PhD scholars. He has published more than 100 research papers in international and national journals. Professor Ahmed has organized 3 international conferences, 4 refresher courses, 5 workshops, and delivered more than 70 extension lectures in academic staff colleges and the department of several universities. He serves Asian Institute of Technology, Bangkok, Thailand under MHRD program during August-December 2016 as a visiting professor. He is the member of the visiting team of the National Council of Evaluation of Teachers. Over to you, sir.
अरे अनम्यूट करो ना इनको, अकील सर को अनम्यूट करो। एडमिन के नाम से अनम्यूट।
Am I audible?
Yes sir, now you are audible sir.
Okay. So thank you, Nazma, for the nice introduction. In fact, I'm really thankful to all of you, especially the organizers, the Honorable Vice Chancellor of the university, Professor Iqbal Saab, who happens to be one of my close friends, Head Department of Computer Science, Dr. Gulfam, and other dignitaries, including the participants and delegates. I'm really glad to be interacting with you, and I was just a day before in Srinagar, and I was the resource person in one of these such programs of data analysis. I don't know how many participants are there in total, because you have not shared the list of the participants. I do not know, I mean, their backgrounds, where they have come from, the delegates, the participants.
More than 100 sir.
More than 100. And what about their backgrounds? In mathematical science, all of them, or some other discipline?
All are from the sciences and technologies.
So fine. If they are from the sciences and technologies, then it will really help me to teach something on data analysis. As rightly pointed out by Dr. Bashir, this is one of the area. Hello. Yes, please. Like Dr. Majid Bashir rightly pointed out, this is the age of data science. And I would like to add that not only the age of data science, but I can certainly say the age of mathematical science and the computer science. In fact, if you use mathematical science and blend it with the applications of computer science, then it becomes the data science. And this data science is the need of the hour. You speak of any industry, you speak of any area, you will find the applications of mathematical sciences as well as the computer science. And I'm very glad to share it with you that the Aligarh Muslim University has started a course on data science leading to the degree of MSc in data science. And we have blended the two. The full dose on mathematical science, which includes mathematics, statistics, and operation research. And of course, the softwares, plus everything you need in computer science, the kind of modules on artificial intelligence, cloud computing, databases, and all machine kind of learning we have included in this course. So, as I still say that if one has to learn something in his life to be happy, to be a good administrator, to be a good manufacturer, to be a good entrepreneur, so this is what he is supposed to learn. And for academics, this is the must. Without these things, one cannot excel in research. Why do I say so? Because you start researching new things, and when you want to get it published, nobody would believe you unless you attach the role of mathematical science in the form of validation of your results, in the form of performing p-values, test of significance, so that whatever you are saying, people must believe it. Because the $100 question today is that ever you have some idea, you have something, you have done something very good in research. The question is why other people should believe you. So the only tool in your hand is that you you suppli- you supplement these results with a lot of test of validity and the test of significance, so that the people will have to believe what you are saying. When Dr. Gulfam approached me, I just wanted to know the level of the background of the students, and I'm happy that most of them are from science streams. If I simply share it with you, that data science we are using every moment in your life. From the time you get up in the morning and you go to the sleeping, even during sleep time, we have been using both of these to arrive at a particular decision. Tomorrow, what you have to do, what kind of weather conditions will be there, which clothes you should put on, what you should eat, what you should not eat, for going travel, when you should start, how much intervening time you need for travel. Even in talking, what should you talk? Should we talk in terms of mathematical science or should we talk in our own language? I believe that if you talk in terms of our subject, perhaps you will be better off. Say, for example, if you would be coming tomorrow for one of the classes in your university and you want to come on time, your organizer wants you that at what time you will report in the department. You will simply say, I will report it at 10 a.m. And if you say you are reporting at 10 a.m., perhaps your statement may go wrong, even if you reach 5 minutes earlier. But if you say, probably, sir, I will try my level best, I will be reaching expectedly around 10, then your statement will 100% be true. Even if you reach 5 minutes earlier or you reach 5 minutes later, still you will be better off. Therefore, when the subject is so important, why should we not learn it? But unfortunate part is that when it comes to the question of learning data analysis, most of the time, the kind of statistics which you are supposed to use is not used. And most of the time, when you come to interpret it, you are not in a position to interpret it the way it should have been interpreted. And thirdly, when you had designed the experiment, the results are not coming out to be significant as you wished. Therefore, if you happen to be a researcher, if you are an academician, so the dose on this data science is must. Yes, it used to be a boring subject earlier, but now it's not that. It's much more beautiful subject than any other subject, provided you are taught the way it should have been taught to you. Why do I say so? I'm saying it so because the kind of mathematical science we are being taught in our schools at intermediate or at even graduate level, we never come across when a teacher teaches you something on mathematical science and he explains to you before he teaches why we are learning mathematical science. Like you will agree with me, if I simply ask you, we have been using a lot of mathematics to simplify our system of equations. And every one of you knows how to solve a system of equation. Say, for example, x plus y is equal to 3, 2x plus 4y is equal to 7. I'm very much sure every one of you can give the answer to my question if I want to solve it for X and Y. But how many of you really know from which place or from which kind of situation these equations have come to you? At least I can certify when I was taught, I never came to know about this. The teacher came and he started writing some equations on the board and gave the methods to solve it, but never told me from where these equations have come. And just to begin with, I'm sure many of you can write down. I tell you today from where these equations come. In fact, these equations come from your everyday life. There are hundreds and hundreds of decisions which you have to take every day by using mathematical science. So please listen carefully. I have given this example many times, but let it be repeated for the sake of application of mathematics. So are you ready, everyone? I need to be responded because this is required nowadays when these electronic gadgets may sometime deceive you. So Nazma, can you hear me? Or anybody, Dr. Gulfam? Is somebody listening to me? I want the response from any one of you, from the participants. Yes, please.
Sir.
Okay, fine. This I will have to do from time to time. Nazma, please tell me how much time is there for me? Because I have not been given the schedule. How much time you have kept it for me, for my lecture? Nazma, hello? Okay, fine. Very good. Somebody is listening. So what is my time so that I can accordingly plan my lecture?
Sir, up to
Yes.
4:30.
Up
So
to
4:20. 4:20, sir.
Okay, 10 minutes maybe for discussions, right?
Okay, easy, sir.
Okay, so everybody is there listening to me now. Yes. I ask my participants to write down something which I simply say. A simple question to all of you. Okay. There were two rows of birds which were flying in the sky. Two group of birds were flying in the sky. And while flying, one of the birds tells the bird in the other group, if two of you come to us, we will be equal to you. In response to this, the bird from the other group tells that if two of you come to us, we will be double to you. I repeat the question. There were two groups of birds flying in the sky. One of the birds in one group tells to the birds of the other group, if two of you come to us, we will be equal. In response to this, the bird from the another group tells that if two of your group comes to us, we will be double to you. Who has the answer? How much? How many number of birds are there in each group? Maybe someone to whom I had told earlier, he may respond quickly. Anyone? Use mathematics. Computer science you cannot use because at this moment you don't have the computers with you. Anyone? Any answer from the audience? I repeat my question. There were two groups in the birds flying in the sky. While flying, one of the birds tells others, if two of you come to us, we will be equal to you. In response to this, the birds from the other group tells that if two of you come to us, we will be double to you. Simple question. This was asked in IS preliminary examination. Anyone, if you can respond. There are hundreds of participants listening to me. I want the answer. This is a high school mathematics, even much lower than that mathematics. Any answer?
Some of the participants are writing in the chat box.
Let them write. Yes, I am getting 4 and 8. This is not the correct answer. Somebody writes 2 into 2 becomes 4. Mathematically, this is sound, but this is not the answer. Anyone? बहुत आसान है. I hope मैं उर्दू में भी आपसे बात कर सकता हूँ. 2 ग्रुप हैं आसमान में बर्ड्स के जो उड़ रहे हैं. एक ग्रुप में एक चिड़िया कहती है कि अगर आप में से 2 हमारी तरफ आ जाएं तो हम आपके बराबर हो जाएं. उसके जवाब में दूसरे ग्रुप में से चिड़िया कहती है कि अगर आप में से 2 आ जाएं तो हम आपके डबल हो जाएंगे. I am getting answers 4, 6. So 4, 6 is not the correct answer. Somebody has written an equation, tried good, x is equal to y plus 2. But this could have been x minus 2 is equal to y plus 2 because 2 birds will go from x. So 4, 6 cannot be the right answer. If 2 of the other birds go to 4, they become 6, and in the another they remain only 4. And let me tell you now, or should I wait for all of you to respond? I want to find out the intelligent mathematician from you. I should get more answers. Are you trying? Yes, please. I want few more answers. I think not getting. Okay, let me write it to you. Let you write that the number of birds in one group is X and the number of birds in another group is Y. Okay? Fine. Now, if you say X and Y, X and Y are the numbers. Are the numbers. Number of birds in 2 groups. So what is your equation? The first equation, if 2 of the birds from X group, they go to another group. So what is the equation? The first equation is X minus 2 is equal to Y plus 2, right? Or you can write it as X minus Y is equal to 4. Now what does it say? It says you rewrite it from the second condition. The second condition says if 2 of Y come to X, then they will be double to you.
Sir, we are not able to see your screen.
Okay, let me share it. अभी मैंने अपना स्क्रीन शेयर भी नहीं किया है. चैट्स में जाइए. अभी तो मैं चैट्स में ही लिख रहा हूँ. चैटिंग में लिख रहा हूँ मैं. शेयर भी स्क्रीन कर लेता हूँ मैं. लेकिन अभी मैंने चैट ही में लिखा है.
ओके सर, ओके.
ठीक है. Have you got it?
यस सर.
अभी शेयर करने पे पैसे जरूर मांग रहा है.
चाय नहीं पीने? चाय कोई दे रहा डगा हुआ तो छाड़ में दानी ने सारे
अब मुझे इसको वापस लाना मुश्किल हो रहा है. Normally I don't use Zoom, but today I had to use it because you had only option for that. Please wait for a minute. Okay. Can you see the chat box? आपको chat box दिख रहा है? और चलिए मैं ये शेयर कर देता हूँ. क्या मेरा पेज देख सकते हैं आप लोग?
Yes, sir.
Yes, sir.
It is visible?
Yes, sir. It is visible.
So please see what I am saying. I am saying x minus 2 is equal to y plus 2.
Sir, please increase font size.
हाँ मैं अभी करता हूँ इसको. ठीक है?
No, okay, sir.
Or you can write it like this: x minus y is equal to how much? 4. Now what is the second condition? The second condition is the bird from the other group says that if 2 of you come to us, that means they will go to x is equal to, this will be y minus 2. And they say we will be double to you. They say they will be double to you. And this will be equal to, so if you simplify this, what you will get? X plus 2 is equal to 2y minus 4. Or you can write it as x minus y, x minus 2y is equal to minus 6. Minus 6. So you have got two equations here. This is one. This is 1 and this is 2. If you solve these two equations, you will get x is equal to 10, y is equal to 14. Now just think, is it correct or not? If you send from y to, they become 12, and in y they remain 12. There is some disturbance coming to me, please. There is a lot of disturbance. Somebody is talking, please. Can you see the solution? Yes, please.
Yes, sir.
Now, do you agree with this solution?
Yes, sir.
Yes, sir.
How did you find it? Using mathematics? Now
Yes, sir.
let me know how many times you were given this application. The teacher used to say, solve the two equations, x minus y is equal to 4 and x minus 2y is equal to minus 6, which we used to solve. But how many times they had applied it to the practical field? Never. This is what is happening with our mathematical science nowadays also. So therefore, it is equally important for us to understand what we need and what we should learn and how it should be taught. Now, because nowadays we don't want that we should perform the manual calculations, we take the advantage of using softwares. And the software which I will be discussing with you is so easy software that even you don't need to learn any kind of programming. You don't need to learn any kind of commands. It will talk to you in terms of English language. But I would like to know your choice of the field which I should talk today for your research problems. I have many topics for you, but would definitely like to talk the topics which you really would love. I have exploratory data analysis. Means once you have the data, what should you do with the data? The first thing to be done with the data, we call it exploratory data analysis. Exploratory data analysis. This is one topic we can discuss. Another is correlation regression. Correlation regression. Then we can also discuss tests of hypothesis. Hypothesis. Test of hypothesis. We can also discuss LPP using softwares. Now, in which topic you are interested? Because in 1 hour, I cannot complete all these. Let you learn one properly and then be relaxed. Which topic you are interested in?
The second one, correlation regression.
Fine. It's very good. Thank you for your response. Now, in nature, most of the variables are correlated. And when they are correlated, we can develop a relationship. We can go for predictions. Imagine कीजिए कल का मौसम कैसा होने वाला है. What will be the weather tomorrow? Or I simply ask you, how long you should live in this world? How long you are expected to live in this world? How long we are expected to live in this world? Anyone? You should know that. Life to aapki hai na bhai. Anyone? How long we are expected to live in this world? Muslims के लिए तो वक्त तय है.
Until we are healthy, sir.
मुस्लिम्स के लिए हम लोग मानते, मुस्लिम्स के लिए हम लोग मानते हैं कि हमारा टाइम लिखा है. उसके आगे एक आगे ना पीछे हो सकता है. बट व्हाट आई एम आस्किंग, हाँ जब ऊपर वाले की मर्जी हो उसके आगे किसी की नहीं चलती. लेकिन अब देखिए मैजिक क्या है. मैजिक ये है डेटा साइंस का. I can tell you even now that as an Indian, we are expected to live up to the age of 69.98 years in this world. If everything goes normal. If everything goes normal means everything will be as normal as today. There will be no war between India and Pakistan. There will be no war elsewhere so that we are affected. If everything goes normal, कोई प्लेग ना आ जाए, कोई कोरोना ना आ जाए, अगर वो नहीं आता उसको हम एबनॉर्मल कहते हैं. So if everything goes normal, we are expected to live in this world up to the age of 69 roughly or 70 years of age. How can I say so? Remember, I can say so because I have used all the variables of the Indian system, Indian health, and it has been calculated that on an average Indians life expectancy nowadays it is 69.9 years. So you can plan your life accordingly. But if you want to live longer, what should I do? A question to you. If I wish to live longer, what you should do?
Eat healthy, sir. Or exercise daily.
हाँ वो भी सही है, but you will have to go to Japan. Do you know why? Because the life expectancy in Japan is 82 plus years. In India, it is 69.9 years. Maybe in Ethiopia, it is only 45. So imagine, using data science, we are telling you how long you are expected to live in this world. Using data science, we are telling you whether tomorrow there will be a rain or there will be a dry weather tomorrow. I'm telling you in advance, this medicine is going to be effective to cure you or not. I'm going to tell you in advance what is going to happen tomorrow to your health. How many more babies are expected to be born tomorrow in your city? How many of them are going to be male? How many of them are going to be females? You only give me last year's data. I can tell you that. What you should eat, what you should not eat. If you want to become fatty, eat this, and that. If you want to be thin, eat like this. I can tell you in advance. And what are the factors which will be responsible for becoming thin or becoming fat? So the correlation in the first thing, in the correlation, we try to find out if our variables are correlated, then we can develop a relationship, a nice relationship between the two variables, between several variables, so that we can make predictions. And if you want to know how do we do that, please remain with me mentally for another 30-40 minutes. The only one thing which we assume that the relationship between the two variables must be there. There must be some kind of relationship between the two variables or several variables. And if you find the relationship, I tell you, you do not need to remember the formulae. You don't have to remember the mathematical analysis. You simply use some commands. You simply use some commands and you will find the results there. In the same way, as if you are using your thermometer. For what do we make use of thermometer? Anyone? For what do we make use of measuring temperature?
Body temperature.
Fine. Before you take the thermometer in your mouth, how many times you ask the doctor on which principle it works? Do you ask the doctor on which principle this thermometer works?
No.
Never. You go for getting the MRI of your body. How many times you ask the doctor on which principle this machine works? Never. Now the subject of statistics and data science has become this same thing for you. The softwares will not ask you to remember the formulae, but definitely it will tell you what are the findings, what are the results. And of course, you should know how to interpret them. I start with some data for you. Like, for example, I hope you would be able to see this. I would be able to show you some data here. Like this. Can you see this data?
Yes, sir.
In the first column, it is written rent. In the second, it is written number of rooms. Third, the distance from the downtown. If you want to take a room on rent, I know that the room rent is directly correlated with the number of rooms and the distance from downtown. Do you agree with that?
Yes, sir.
Now, how to make the relationship, isko hum kehte hain mathematical modeling. How to make this relationship in the form of a mathematical modeling, that I want to know what will be the rent I have to pay if I choose the number of rooms, if I choose the distance from the downtown. Because I believe if the distance from the downtown is more, it is less costly. If it is very much in the downtown, then it may be very, if it is far away, it is cheaper. And if it is very closer, it is very costly. So this is the data. Now, what should I make use of this data for correlation and regression? If you want to find out the correlation between the two, The number of rooms will be correlated with the rent. The distance from the downtown, it will be related with the rent. So what should I do? If I want to use this data, first of all, I would like to find the matrix of correlation. This is the first thing which you should do. If you find that the two variables are correlated, only then you should go ahead. Otherwise not. And I call it the matrix plot. You can plot it only two variables also. And using everything MiniTab, everything you will be making use of the software. So this is the ready-made plot. I know that this is correlated, this is correlated, this is less correlated, this is less correlated, this is also less correlated. So first of all, you have to plot the relationship between the variables. And if you find that the variables are correlated, go for the relationship. The relationship is this one. This is the correlation. Correlation between number of rooms and rent, it is 0.956. That means the number of rooms and the rent is directly related. It's a high degree of correlation. And whether this is significant or not, this is p-value. This is highly significant. In statistics, if anything result is lower than 0.05, p-value is 0.05, less than 0.05, then these results are significant. Distance and rent, it is correlated but with negative sign. Can anybody interpret? What does it mean?
Sir, inverse proportionality perhaps.
Yes. If the distance is more, the rent will be low. If the distance is closer, the rent will be high. So it shows that there is some relationship. So I should build up the advanced mathematical modeling equation. So I will use MiniTab and simply see here. What is the regression equation which comes? Rent is equal to 822 plus 1384 into number of rooms. Okay. What is the regression equation? Rent is equal to 822 plus 1384 into number of rooms. I am taking only two variables at the moment. It says if I want to find out how much rent I have to pay, you tell me only the number of rooms, I will tell you how much rent you have to pay. Say for example, if I need a room of, I need a flat of one room only. So what will be the total rent to be paid by you? 822 plus 1384 into 1 means 1384 plus 820, roughly 2000 plus. If I need one single room, right? But what I need, if I need two, if I need the distance also into account, then you will be performing it, the multiple regression equation, and it is easy to perform in the using the MiniTab software. What I want, please, someone should note it down, this data, please, so that I can remember it again. Can you write down this? So when feeding into the software, you please let me know. The first entry is 3600. Number of rooms is 2. Distance is 1 kilometer. Class हेलो हाँ मैं क्लास में हूँ जरा. So have you noted it down? मोबाइल से आप फोटो भी ले सकते हैं.
Yes sir.
ले लिया? ठीक
Yes,
है.
sir,
अब देखिए, अब मैं आपको मैजिक सिखाता हूँ. मैजिक इसमें है, ये सॉफ्टवेयर की कॉपी मैं आपको दे दूंगा, आप जब भी चाहिएगा आपको. क्या लिखा है यहाँ पे? MiniTab.
MiniTab.
And the file which I will give you, you just click on MiniTab, you double click it here and the magic will come to you. आपका पहला कॉलम क्या था? रेंट का था. लिखिए यहाँ पे रेंट. पहला कॉलम क्या है? रेंट है ना, जो डेटा मैंने आपको दिया है. जो
Yes,
अभी
sir.
बात हो, हाँ दूसरे में क्या लिखा है?
Number of room.
तो आप इसको ऐसे लिख सकते हैं, नंबर ऑफ रूम्स, है ना? और तीसरे में
Yes.
क्या है?
Distance from downtown.
डिस्टेंस। ठीक है, अब मुझे खाली ये नंबर बता दीजिए। पहला नंबर कितना है? 3600।
3600.
नंबर ऑफ रूम्स 2,
2,
डिस्टेंस
1.
1 किलोमीटर। चेक कर लें, ठीक है?
Okay. Yes, sir.
दूसरे में
10,000.
10,000।
6.
नंबर ऑफ रूम्स, नंबर ऑफ रूम्स कितना?
6.
6। और डिस्टेंस
6.
6
1.
नहीं, 1 है, 1 किलोमीटर।
Yes.
अच्छा, फिर तीसरे में
4500.
4500।
3.
और नंबर ऑफ रूम्स
3.
3। डिस्टेंस कितनी है?
Distance 2.
2। और यहाँ चौथे में रेंट कितना है?
5250.
5250। नंबर ऑफ रूम्स
4.
4। डिस्टेंस
3.
3। देन रेंट कितना है? 4500।
3500. 3500.
3500, ठीक है।
Yes, sir.
3500। देन
2.
2।
10.
देन 1।
10.
और भी है? और
10.
भी है? बस
Distance is 10.
डिस्टेंस इज
10. 10.
10। ओके।
Yes, sir. एक और कॉलम है सर।
हाँ बताइए।
3000.
3000।
1
1
and 4.
4। डेटा को एक बार जरूर चेक कर लें दोबारा, ये
Yes.
यही है या कुछ और है? अगर आप कहेंगे फाइन ठीक है तो मैं आगे बढ़ता हूँ।
ठीक है सर, ठीक है।
अब देखिए, मैं मैजिक आपको सिखाता हूँ। आपको कोई मैथमेटिकल साइंस नहीं आती, ठीक है? मैं इसमें कोरिलेशन निकालना चाहता हूँ बिटवीन रेंट एंड नंबर ऑफ रूम्स। देखिए कितना आसान है, ना आपको फॉर्मूला याद करना है ना कुछ करना है। कहा देखिए ये लिखा है, क्या लिखा है देखिए, कैन यू रीड इट? ये जहां मेरा कर्सर है, स्टार्ट। बस इसको क्लिक कर लीजिए एक बार। क्लिक किया, फिर नीचे बेसिक स्टैटिस्टिक्स लिखा है, इसको क्लिक कर लीजिए। देखिए जहां आपको कोरिलेशन मिलेगा कहीं, कहाँ है?
लास्ट में।
हाँ, आप क्लिक कर दीजिए।
Yes.
किया? अब बताइए किस किस के बीच में कोरिलेशन निकालना चाहते हैं? रेंट और नंबर ऑफ रूम्स।
नंबर ऑफ रूम्स। यस सर।
सेलेक्ट कर लीजिए, तो ये कटघरे में आ गया।
यस।
जस्ट प्रेस ओके। ये आपका कोरिलेशन है यार। आपने कौन सा फॉर्मूला याद लगाया इसमें? मैंने तो नहीं पूछा।
कोई नहीं सर, बैक एंड पे खुद।
देखिए आपका कोरिलेशन निकल के आ गया, पी वैल्यू निकल के आ गई। और अगर आप दूसरों में भी कोरिलेशन निकालना चाहते हैं तो ये है, आप दोबारा जाइए। अभी आपने किस किस में निकाला था? रेंट और नंबर ऑफ रूम्स में। अब आप रेंट और डिस्टेंस में निकाल लीजिए। ये आ गया, ये देखिए रेंट और डिस्टेंस में कितना है? -0.436। पी वैल्यू क्या है? ये सिग्निफिकेंट नहीं है। एक और भी निकाल सकते हैं। कोरिलेशन में जाइए, तो हमने 1 और 2 का निकाला, 1 और 3 का निकाला। अगर आप चाहते हैं 2 और 3 का, नंबर ऑफ रूम एंड डिस्टेंस, ये कोरिलेशन यहाँ आ गया। तो कितना आसान है कोरिलेशन निकालना। अगर इसको प्लॉट करना चाहते हैं तो देखिए कितना आसान है प्लॉट करना। आप ग्राफ में गए, प्लॉटिंग किस में होती है? ग्राफ में।
ग्राफ्स में।
आप स्कैटर प्लॉट पे कर लीजिए एक बार क्लिक बस। ये आपसे पूछता है इसमें कौन सी आपको पिक्चर चाहिए। मान लीजिए सिंपल चाहिए, ओके कर लीजिए। फिर आपसे पूछता है वाई वेरिएबल कौन सा है। वाई वेरिएबल हमेशा हम डिपेंडेंट वेरिएबल लेते हैं, याद रखिए। वी टेक द वेरिएबल एज डिपेंडेंट वेरिएबल which is influenced by independent variables, और y वेरिएबल उसी को कहते हैं। हमने आपको वो भी दी थी, y is equal to 822 plus 1384 into the number of roots, जो हमारी रिग्रेशन लाइन थी। तो y वेरिएबल में हमेशा डिपेंडेंट वेरिएबल और इंडिपेंडेंट में कोई सा भी ले लीजिए, ठीक है? ये मुश्किल तो नहीं है?
नहीं सर।
अब ओके कर लीजिए, आपको वो मिल जाएगा ग्राफ। ये पहली बार में नहीं करेगा, दूसरी में करेगा। ग्राफ में जाइए, स्कैटर प्लॉट, ओके एंड ओके, कंटिन्यू। देखिए आपके पास क्या आ गया भाई, प्लॉटिंग कितनी आसान है, ठीक है?
आसान है सर। यस।
अब ये हमें यहां से दिख रहा है कि पॉजिटिव कोरिलेशन है, बस काम बन गया। अब हमें इस पे एडवांस्ड एनालिसिस लगानी चाहिए। एडवांस्ड एनालिसिस क्या करूंगा मैं यूज? मैं जानना चाहता हूं कि अगर मुझे कोई रूम रेंट चाहिए, कोई रूम चाहिए रेंट पे, तो मुझे कितना रेंट पे करना पड़ेगा। ये जो नए लेक्चरर्स हैं उन्होंने सबने फेस किया होगा बेचारों ने, लेकिन क्या कभी आपने मैथमेटिकल मॉडलिंग की? नहीं। आपने तो किसी से पूछा उस मोहल्ले में कितने में मिलेगा, इस मोहल्ले में कितने में मिलेगा। आपने साइंस तो कभी यूज की नहीं। साइंस यूज कीजिए। देखिए जहां पे आपको जाना है, कहाँ पे? रिग्रेशन में। कौन सी रिग्रेशन में? इतनी सारी रिग्रेशन एनालिसिस होती हैं। रिग्रेशन, स्टेप वाइज रिग्रेशन, बेस्ट सबसेट, फिटेड लाइन प्लॉट, partial least square, binary logistic, ordinary logistic, nominal logistic regression। ये मैं आपको सारी सिखा सकता हूँ, लेकिन टाइम की कमी है, इसलिए सिंपल आपको थोड़ा सा लालच दे रहा हूँ। रिग्रेशन यूज कीजिए, सिंपल वन। लेकिन आपके पास में रेस्पॉन्स वेरिएबल कौन सा है भाई? डिपेंडेंट वेरिएबल कौन सा है? रेंट
सर। रेंट।
इसको रेंट को रेस्पॉन्स वेरिएबल भी कहते हैं, ठीक है? ये डिपेंडेंट वेरिएबल हुआ। इंडिपेंडेंट वेरिएबल्स कौन से हैं?
नंबर ऑफ रूम्स।
अगर आप पहले एक लेंगे तो वो भी करके देख सकते हैं। पहले एक के साथ, हाँ पहले एक के साथ कर लीजिए, ओके कर लीजिए। आपके रिग्रेशन लाइन क्या आई? कितनी आई भाई? रेंट इज इक्वल टू 822 प्लस 1384 इंटू नंबर ऑफ रूम्स। तो मैं यहाँ पे डिस्टेंस को अकाउंट फॉर नहीं कर रहा हूँ। मेरे पास गाड़ी है, मुझे डिस्टेंस की कोई फिक्र नहीं है, तो अगर 10 किलोमीटर दूर भी मिलेगा आई डोंट माइंड। तो फिर आपको नंबर ऑफ रूम्स ही तो लेना है। ये रिग्रेशन लाइन है। लेकिन यहाँ देखिए ये कितने, ये 89.4% लिखा है। इसका मतलब ये है कि आपका मॉडल 89.4% ही इफेक्टिव है। और मुझे मालूम है कि इसमें डिस्टेंस भी होनी चाहिए। तो मैं क्या करता हूँ, मैं दोबारा इसको रिग्रेशन में जाता हूँ और वहां पे दो इंडिपेंडेंट वेरिएबल ले लेता हूँ, एक वेरिएबल और ले लेता हूँ यहाँ पे। इनको आप यहाँ से सेलेक्ट कर लें दोनों को। डिस्टेंस हो गया, यहाँ दोनों वेरिएबल ले लें आप एक साथ। तो ये आपका हो गया एग्जाम्पल ऑफ मल्टीपल रिग्रेशन एनालिसिस in which you have only one dependent variable and there are two independent variables। देखिए आपकी रिग्रेशन इक्वेशन क्या आती है। रिग्रेशन इक्वेशन कितनी आई आपकी? ये है रिग्रेशन इक्वेशन। देखिए चेंज हो गई। अगर आप डिस्टेंस को भी मद्देनजर रखना चाहते हैं तो रेंट इज इक्वल टू 965 प्लस 1365 इंटू नंबर ऑफ रूम्स माइनस 24 इंटू डिस्टेंस। ये आपके रिग्रेशन लाइन है। अगर मुझे जानना है कि अगर मुझे कितने कमरे चाहिए, कितनी दूर पे चाहिए, तो मैं घर बैठे रेंट डिसाइड कर सकता हूं। अब आ जाइए इसके नीचे, पी वैल्यूज के ऊपर नजर मारिए आप प्लीज। पी वैल्यू कांस्टेंट की कितनी है? 0.474। इज इट सिग्निफिकेंट? स्टैटिस्टिक्स में वी से any p value which is less than 0.05 is significant. This is a rule. Now how many of these are significant? Constant कितना है? Is it less than 0.05?
Yes, sir.
Sure?
Yes, sir. Sure.
No. 0.47. And I am comparing it with 0.05. 0.05. So
0.05, not
yes.
0.5.
No. I am comparing with p value. हम लोग लेते हैं ना p value p is equal to 0.05.
Yes, sir. Sir, it is greater than.
हम लेते हैं हमेशा p is equal to, p should be less or equal to, है ना? p should be less than 0.05. तो क्या ये यहाँ less than है इससे या greater than?
Greater than.
तो ये significant नहीं है, ये significantly contribute नहीं कर रहा है, significantly not contributing. Okay? और दूसरे वाले के बारे में क्या ख्याल है? ये कितनी वैल्यू है? What is this value?
Less than.
Less than. So what we will write here? What we will conclude here?
Significant.
This is significant. What about the third one? Third one is 0.876. Yes. It is significant or not?
Not.
So this is not significantly contributing. किसको? मैंने बता दिया था. कर दिया मैंने. So out of 3, only 1 is significantly contributing. Means what? ये जो डेटा है आपका रेंट का, इस रेंट के डेटा में मैं कह सकता हूं कि डिस्टेंस इज नॉट प्लेइंग ए रोल. ये हो सकता है पहाड़ों का कोई डेटा है. पहाड़ों में डिस्टेंस क्या मैटर करती है? क्यों भाई? राजौरी में अगर कोई मकान थोड़ा सा दूर भी है तो क्या कोई प्रॉब्लम है? नहीं है. लेकिन दिल्ली में है, वो डिस्टेंस भी मैटर करती है. क्यों? दिल्ली में सुबह निकलेंगे और दूर अगर आप हैं तो 2 घंटे जाने में लगे. So therefore, this is the regression model. अब मुझे आप ईमानदारी से बताइए, क्या आपने इसमें कोई फॉर्मूला कहीं देखा है कि रिग्रेशन कैसे करते हैं? देखा है कहीं?
Yes, sir.
इसमें मैंने कोई फॉर्मूला आपको नहीं दिया भाई, आपके सामने रिजल्ट्स हैं. और यही
सर,
तो चाहिए आप. हाँ, यही तो चाहिए आपको एज ए रिसर्चर. जो स्टैटिस्टिक्स में रिसर्च कर रहे हैं उनको तो चाहिए फॉर्मूला किस तरह से डेवलप हुआ है. आपको कहाँ चाहिए? आपको तो थर्मामीटर मुंह में लगाना है और उसकी मेजरमेंट देनी है. तो आजकल डेटा साइंस. यस प्लीज.
कैन आई प्रोसीड सर?
यस प्लीज.
सर जैसे इसने दिखाई ना, वहां से एक रिग्रेशन इक्वेशन हमें मॉडल करके, उसके मतलब इंटरसेप्ट भी दिया और कोएफिशिएंट्स भी दिए वेरिएबल्स के साथ. सर इज इट द ओनली बेस्ट रिग्रेशन इक्वेशन और देयर इज अ पॉसिबिलिटी ऑफ हैविंग अ बेटर इक्वेशन?
वेरी गुड क्वेश्चन. We will base our argument on this. What is written over here?
Sir, 85.9%.
So this says that this model is effective. How much? 85% only.
Okay, sir.
It means that we should have included some more variable. Right?
Yes, sir. Yes.
So some variable is missing. I can include some more variable here. Then this fitting, this will become more than 90%. And I show you one of the such data, which I will share it with you. What is this model? Just look. I explain you, this is the data from 11 chicks. Chicks किसे कहते हैं बेटा? भाई, chicks कहते हैं मुर्गी के बच्चे को, राइट? चूजे. इनका वेट है 11 दिन तक लिया गया, 11 सैंपल्स लिए गए और चूजे का वेट था 0.029 पाउंड जब वो 6 दिन का था. इसका वेट था 0.052 जब वो 7 दिन का था, इसका वेट था 0.079 पाउंड जब वो 8 दिन का था। तो अगर मैं इंटरेस्टेड हूँ वेट इंक्रीजिंग में, चूजे का में काहे में इंटरेस्ट होते हैं हम आजकल? वी आर इंटरेस्टेड ओनली इन द वेट्स ऑफ दीज चिक्स, है कि नहीं? हम चाहते हैं कि 15 दिन में ही खाने लायक हो जाए, 2 किलो का हो जाए। सो आई वांट टू नो whether age is contributing in the weight or not, right? So what I will do, first of all, I will find the way, I will find the regression line. Regression line कितनी है? -1.88 plus 0.235 into h. लेकिन यहां मैंने एक चीज जो आपके साथ शेयर नहीं की है, चूंकि आप अभी सिंपल बिगनर्स हैं, जब भी कोरिलेशन रिग्रेशन की बात करें तो रिग्रेशन एंड कोरिलेशन की बात अगर करेंगे तो रिलेशनशिप लीनियर होनी चाहिए। लेकिन जब मैंने प्लॉट किए तो ये रिलेशनशिप कैसी है भाई? वेट और एज की रिलेशनशिप कैसी है? क्या ये लीनियर है?
नो सर, इट फॉर्म्स अ कर्व।
It is a curvilinear relationship.
Yes.
So a person from statistics, a person who knows data analysis will not make use of this relationship. But those who are not from statistics, who are not from data analysis, they will make use of this. But they do not know that they cannot apply the regression analysis, linear multiple regression analysis, or simple linear regression analysis, because the relationship is not linear. So what should I do? If you are the beginner, you will perform the analysis and you will make a mistake. And what will happen? The predictions will not be accurate. The predictions will not be accurate. Why? Because you are not using the linear relationship. Now, if it doesn't show the linear relationship, mathematically, I can make it linear. I can make it linear. How? Just see. I will transform this data. I will transform this data. How I will transform this data? I will use, instead of weight, I will use log weight. Instead of weight, I will use log weight. So weight का अगर log ले लें, so this will become log weight. And now I will plot it against age. So if I plot the weight against a log weight against age, this is the picture. Now what is this?
Linear.
Is this almost linear?
Almost, yes sir, almost.
This is just equal to when, if you happen to be the teacher, आपकी क्लास में नॉन डिसिप्लिन्ड बच्चा आया, तो आप क्या करते? यू मेक हिम ट्रांसफॉर्म्ड. कैसे? मोहब्बत से, पिटाई से, ट्रेनिंग से. और जब आपके यहाँ से डिग्री लेके जाता है तो वो डिसिप्लिन्ड हुआ कि नहीं? जब आया वो डिसिप्लिन्ड नहीं था, आपने कर दिया, तो आपने क्या किया? हम उसको क्या कहते हैं? ट्रांसफॉर्मेशन. मैथमेटिकल ट्रांसफॉर्मेशन ये है कि आप अपने नॉन लीनियर डेटा को लीनियर भी बना सकते हैं. मैंने कौन सा चीज यूज की है? मैंने इंस्टेड ऑफ यूजिंग वेट, आई हैव यूज्ड लॉग वेट, राइट? एंड योर डेटा हैज बिकम लीनियर. So I am happy. But maybe most of you people, they don't know how to transform. We transform the data by taking log x. We transform the data by taking the reciprocal of the actual values, and sometimes we take the exponential also. So now I am comfortable with this. So I will perform the regression analysis now. Your regression equation has changed. Remember, it has become log weight is equal to -2.69 plus 0.196 into h. Now tell me, what was the level if I want to use earlier? If I wanted to find the weight and age relationship, what was the level of adequacy? How much model was accurate? Model कितने percent? मॉडल कितने परसेंट फिट था?
71.6.
So, but I ask you, if your car is only 71% effective, which you want to buy, should you buy that car? If it is only 71% effective,
No, sir.
कौन खरीदेगा उसे? But if your car is 100% effective, everybody would like to buy that.
Yes.
Yes, sir.
Now, so what I have done, either use this model for prediction of weight of chicks, you are only 71% confident. But if you want to use another model, data wahi hai. If you want to use another model, what is the R square adjusted, fitting, adequacy? How effective your model is here?
Almost 100%.
Almost 100%. So which model you would like to use for prediction?
The later one.
The later one. It shows you are almost 99.8% confident that your model will be predicting, forecasting what you are looking for. अगर मैथमेटिकल साइंस ऐसे यूज करें तो कभी आपको धोखा नहीं होगा. अदरवाइज व्हाट हैपेंस, पिछले दिनों ट्रंप ने बताया था कितने लोग जो है वो मर जाएंगे अमेरिका में, किससे? कोविड से. उसने बिलियंस एंड मिलियंस ऑफ पीपल बता दिए थे, लेकिन वहां के डेटा एनालिस्ट ने कहा कि ही इज टेलिंग यू द लाई, क्योंकि इनको अगर वो मैथमेटिक्स नहीं आता है. उन्होंने फिर उस डेटा को करेक्ट किया. और आज भी अगर कोई ये जानना चाहते हैं हाउ मेनी पीपल आर लाइकली टू बी अफेक्टेड बाय कोरोना, अगर आपने मॉडलिंग ठीक से नहीं की है तो फिर उल्टे रिजल्ट्स आएंगे. बिल्कुल उसी तरह से जब हम 1975 में टीवी देखते थे तो रात को वहां पे प्रेडिक्शन होता था कल को बारिश होगी और अगले दिन धूप खिली होती थी. और अब क्या अब भी ऐसे ही हो रहा है? बताइए ईमानदारी से.
नो सर, आजकल प्रिडिक्शन बहुत अच्छी होती है वेदर की.
बहुत अच्छे हो रहे हैं. I can certainly tell you, if there is a one-day match which is being played in England, of Africa, or somewhere Australia, or in India or Pakistan, then they will go they give you the weather summary before the match starts, and they will tell you whether there is a chance of rain or not. If they say around 3 p.m. the showers will come, take it from me, it will come. And if they say the weather would remain pleasant, so it will remain pleasant. Why? Because now mathematical modeling has become more sharp, more scientific. And these are the indicators. If your variables are all there which are sufficient to predict, it means that you are 99.8% confident. I don't need any other variable to be included. Right? So don't you think this is a magic? We are predicting what is going to happen. I'm telling you in advance, tomorrow there will be rains. I'm telling you in advance, if you eat this, you will become opposite. Obesity will be there in your body. After becoming 45 years of age, you should not eat this, and this. And how much ice cream you should take every day, your fat contents will increase. Now it is every kind of mathematical science. And don't you think, whatever I am telling you, should others believe me what I am saying? I am saying use log weight is equal to minus 2.69 plus 0.196 into age. With how much confidence I am saying? What is the p-value here? What is the p-value here?
0.
Yes, it is highly significant. It is highly significant. So ever if you don't want to believe what I am saying, you will have to believe. Don't you think this is a science? नहीं तो आजकल कौन किसकी बात मानता है? हर आदमी कहता मैं ईमानदार हूं, तो बेईमान तो कोई है ही नहीं. तो क्या हमें ऐसे मानना है उसको, या हमें इसको साइंटिफिक बेसिस पे यूज करना है? If I am saying the weight of the chicks can be determined using log weight is equal to minus 2.69 plus 0.196 into age, so इस डेटा के बारे में मैं कह रहा हूं, and nobody on earth can simply refute my statement. Why? Because the model says I am 99% plus 8% effective. So this is what I stated in before my lecture. Statistics is a subject which will make you compatible with getting your hypothesis believed by other people. नहीं तो आपने रिसर्च की है, दूसरे लोग क्यों यकीन करें? आपने रिसर्च की है, दूसरे लोग यकीन इसीलिए करेंगे because you are using the scientific things here, you are using model adequacy, you are using p values. So I think the time doesn't permit me anymore. Or can I continue? Please let me know.
Yes, sir, you can continue up to 10-minute modes.
Okay. But maybe we can give only 5 minutes more and 5 minutes for discussions.
Yes, sir.
Right?
It is okay.
Now see, 99.8% effective model. Even if I know that I'm really very much sure that this is the right model, but somebody can tell me, why don't you make use of 2 more variables? These 2 more variables can increase the weight of the chicks. What are those? Somebody says, include these 2 variables more. Length of the chicks and HB level of the chick. मानते हैं कि अगर उसकी लंबाई चिक की ज्यादा होगी तो वेट ज्यादा बढ़ेगा?
Yes, sir.
Possibility है.
और अगर उसमें HB लेवल उसके खून में ज्यादा हो तो ज्यादा वेटफुल होगा, मानते हैं?
Possibility, sir.
पॉसिबिलिटी है. लेट अस एक्सप्लोर. तो मैंने क्या किया, इन दोनों वेरिएबल को इंक्लूड किया. किसमें? मेरी रिग्रेशन लाइन में. तो लॉग वेट किसके बराबर आया? ये आपके रिग्रेशन लाइन आई. तो इसमें 2 वेरिएबल और अंदर आ गए. ठीक है. नाउ सी द पी वैल्यू फॉर लेंथ. पी वैल्यू लेंथ की कितनी है भाई? पी वैल्यू फॉर लेंथ
0.6.
Is it significant?
Yes, sir. It is greater than 0.06.
तो significant किसको कहते हैं? If it is less than
0.05.
हाँ, अगर 0.05 से लेस देन है तो हम उसको सिग्निफिकेंट मानते हैं. अगर 0.05 से लेस देन है, क्या ये लेस देन है?
No, sir. It's way higher.
It's very higher. So length is not contributing to the weight of the chicks. अब चिक्स की आपकी जान बच गई. क्यों? नहीं तो पोल्ट्री वाले रोजाना चिक्स को जाके रोज खींचते, लंबाई बढ़ाते उनकी, है ना? अब नहीं कर सकते क्योंकि कोई फायदा नहीं हो रहा ना. अब लेंथ से तो कोई प्रॉब्लम नहीं, लेंथ कुछ कंट्रीब्यूट ही नहीं कर रही. लेंथ इज नॉट कंट्रीब्यूटिंग टू द वेट ऑफ द चिक्स. तो वो चाहे उनको कितना लंबा खींचते रहे, कौन सा फर्क पड़ेगा? व्हाट अबाउट एचबी लेवल? एचबी लेवल 0.05 से कम है, ज्यादा है?
ज्यादा है.
So this is also not significantly contributing.
Yes.
इसका मतलब क्या है कि अगर आप उनको इंजेक्शन लगा भी दोगे एचबी लेवल के तो भी वेट बढ़ने वाला नहीं है. तो इन चिक्स की उसमें भी जान बच गई. इनको इंजेक्शन जो है एचबी लेवल का पोल्ट्री वाले नहीं लगाएंगे. अब अनएथिकल चीज है, आजकल पोल्ट्री वाले कौन सा इंजेक्शन लगा रहे हैं चिक्स को?
वैक्सीन का होता है सर.
वैक्सीन. उनको शराब पिलाई जा रही है ताकि वो 15 दिन में ही 3 किलो के हो जाए. लेकिन यहाँ साइंटिफिकली ये आपको दोनों चीजें कंट्रीब्यूट नहीं करती हैं. अब ये हो सकता है, आप ये इल्जाम लगा सकते हैं कि कोई स्टैटिस्टिशियन ही होगा जिसने बताया होगा इनको कि इनको क्या पिलाने से कितना वेट बढ़ जाएगा. बट ये तो साइंस है भाई. इसको अगर मिस यूज करेंगे तो फिर अल्लाह ही मालिक है. हमको इसको मिस यूज नहीं करना है. सो आप अपनी एनालिसिस से इन दोनों को हटा सकते हैं, दे आर नॉट सिग्निफिकेंटली कंट्रीब्यूटिंग। क्यों? क्योंकि आपकी मॉडल एडुकेसी कितनी है इसमें? मॉडल एडुकेसी कितनी है?
99.8।
तो 99.8 तो पहले भी थी 2 वेरिएबल में। जब हमने 2 इंडिपेंडेंट वेरिएबल लिए थे तो एडुकेसी तो वहां 99.8 ही थी। तो फिर ये क्या फायदा इनको इंक्लूड करने से? देयरफॉर यही, इसी को हम मैथमेटिकल मॉडलिंग कहते हैं, यही रिग्रेशन एंड कोरिलेशन एनालिसिस कहलाती है। आई थिंक इस यही रुकते हैं क्योंकि टाइम हो रहा है। आपके लिए टाइम है टू आस्क एनी क्वेश्चन। आई लव आंसरिंग क्वेश्चंस, प्लीज।
Sir, I have a question regarding
please.
this. Sir,
Fine.
what is the credibility of p value in itself? I mean, how can we? Why are we saying like we are being sure on p value itself?
Fine. एक एग्जांपल मैं देता हूं आपको। जब मरीज के ऊपर ऑपरेशन करते हैं हम, उसको हम क्या पिलाते हैं? किसी का ऑपरेशन होना हो,
एनेस्थीसिया सर, लाइक
एनेस्थीसिया देते हैं सर।
एनेस्थीसिया देते हैं। कितने लीटर देते हैं?
सर इन ml देते हैं।
ml, 1 ड्रॉप 2 ड्रॉप है ना?
सर 3 to 5 ml।
चलिए ठीक है, 3 to 5 ml ही। कितना अमाउंट है ये? हल्का सा है, छोटा सा है ना। आप तो 10-20 गिलास पानी के पीते हैं, और ये कितना दे रहे हैं? 3-4 ml। ठीक है। और जब आपने एनेस्थीसिया दिया तो पेशेंट क्या हो जाता है? एनेस्थीसिया के बाद पेशेंट क्या करता है?
सर होश में नहीं रहता।
होश में नहीं रहता। ठीक है। ईमानदारी से बताइए, जब किसी का ऑपरेशन हो रहा होता है, क्या उसको बीच में होश आ गया हो? कभी आपने कोई केस सुना हो और वो मरीज उठ के भाग गया हो, या उसने डॉक्टर्स की पिटाई कर दी हो? क्योंकि अगर डॉक्टर ऑपरेशन कर रहे थे उसकी टांग काटने का, और उसको होश आ जाए, तो डॉक्टर्स का क्या हाल करेगा बताइए? कभी आपने देखा है कि उसको होश आया है बीच में?
दैट हो सकता है ये।
नहीं, हो सकता है, लेकिन मुझे बताइए कभी हुआ है? कभी हुआ है? क्यों नहीं हुआ है? वहां हम पी वैल्यू क्या लेते हैं? जब ये हम नई दवा डेवलप करते हैं ना एनेस्थीसिया की, तो पी वैल्यू कितनी लेते हैं? वेरी 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 लो, विच इज वेरी क्लोज टू ऑलमोस्ट 0.000, वेरी क्लोज टू 0। इसका मतलब ये है कि मान लीजिए अगर ये लैक्स में है ना, ये अगर लैक्स में है, इसका मतलब ये है कि अगर वो मेडिसिन आपने 1 लाख पेशेंट को दी और उसमें से एक कोई वापस आ गया होश में, इसका मतलब ये है। तो हम वहां पी वैल्यू बहुत लो लेते हैं। और अब बताइए कि पी वैल्यू को हमको ट्रस्ट करना चाहिए कि नहीं? बताइए, ट्रस्ट करना चाहिए कि नहीं? एग्जाम्पल तो आपके सामने है।
एक्सप्लोरेटरी, लेकिन हम ये भी तो कह सकते हैं सर, ये डेटा डिपेंडेंट है। मतलब पी भी तो हम डेटा से ही लेते हैं। वी कैन, आई मीन डेटा कैन ट्रिक अस। अगर हमने प्रॉपर डेटा नहीं लिया है, मतलब सैंपलिंग कुछ हुई है
नहीं,
पार्शियल,
उसका तरीका ये है। देखिए मैं बताता हूँ, हम क्या करते हैं, मिनीटैब में हम डेटा को देख लेते हैं पहले कि ये डेटा नॉर्मल है कि नहीं, हम तभी आगे बढ़ेंगे। जैसे फॉर एग्जांपल मैं एक डेटा आपको देता हूँ। मान लीजिए ये डेटा है, मैं एक डेटा देता हूँ आपको, एक डेटा में देता हूँ, फिर उसको टेस्ट करिए आप। ये कोई डेटा है और इसमें वेट को ले लीजिए आप। ठीक है, आप खुद भी टेस्ट कर सकते हैं, वैसे ये सुपरवाइजर्स को करना चाहिए। आप जाइए बेसिक स्टैटिस्टिक्स में, जहाँ क्या लिखा है भाई, व्हाट इज रिटन ओवर हियर? क्या लिखा है?
नॉर्मलिटी टेस्ट।
सो इसको अप्लाई कर लीजिए। 3 टेस्ट होते हैं आपके पास, ये देखने के लिए कि हमारा डेटा ठीक है कि नहीं। एंडरसन डार्लिंग टेस्ट, ये हम यूज करेंगे। ठीक है, कर ले।
यस यस।
हाँ ये, लेकिन वो वाली डार्लिंग नहीं है जिसको सोच रहे हैं आप। कौन से वेरिएबल को करेंगे? मान लो चेस्ट जी का देखना चाहते हैं या वेट का देखना चाहते हैं कि नॉर्मल है कि नहीं। ओके कर लीजिए। ओके किया, क्या आया डेटा? ये आया। अगर ये डेटा पॉइंट्स इस लाइन के आसपास ही हैं एक्सट्रीम में छोड़ के, तो ये डेटा नॉर्मल है। देखिए पॉइंट्स अगर यहाँ हो बहुत बहुत दूर हो, तो तब ये डेटा नॉर्मल नहीं है। तो अगर डेटा नॉर्मल नहीं है या डेटा अच्छा नहीं है, तो फिर हम इसको यूज नहीं करते भाई। हम तो पहले ही पता लगा लेते हैं कि जो हमारा रिसर्च स्कॉलर है वो डेटा कैसा लाया है। जैसे फॉर एग्जांपल मैं एक और दिखाता हूँ आपको। आप ओपन कीजिए और ये फाइल है जहाँ पे ये फाइल है, इसमें डेटा है कुछ। तो मैं एक डेटा को आपको करके दिखाता हूँ। नॉर्मलिटी देखनी है, नॉर्मलिटी है। इसको देखिए आप, इसको ये देखिए, ये ब्लड वाली लाइन कैसी दिख रही है?
सर बिल्कुल फिट हो रही है उस लाइन पे।
क्यों फिट हो रही है पता है? ये डेटा फॉरेन का डेटा है।
Yes.
ये डेटा हमने नहीं इकट्ठा किया है। और अगर ये हम करेंगे तो आप जान सकते हैं ये
होगा फिर।
सो टेल मी ऑनेस्टली, क्या पी वैल्यू को डिपेंड करना चाहिए हमें? नहीं।
Yes, sir. Obviously.
So if you have any other question, please. Anybody else?
Thank you, sir. Thank you very much.
No, sir. Thank you.
So Nazma, you are there?
Yes, sir.
So thank you so much for giving me an opportunity.
Thank you, sir. Thank you so much, sir.
And that's what I could do in a very short time.
Now it's a time for tea break. The program will resume after 10 minutes.
Thank you, sir. Thank you, sir. Please spare the time for us.
Okay, my pleasure. See you.
Sir, can we download this MiniTab from somewhere?
Yes, please. Let me tell you, you can download it from the Google. Simply write trial version of MiniTab.
Okay, sir. Thank you.
It will work for you for 1 month.
Okay, sir.
And will ask you to give only email. That's all. If you
Okay,
like
sir.
it, if you like it, then the latest version will be around 25,000 only. It's very cheap software. Unlike SPSS, you will have to pay more than 2 lakhs of rupees.
Yes. Okay, sir. Thank you.
So thank you so much.
Participants, please put on your cameras so we can take a group photo. सब प्लीज अपना कैमरा ऑन करेंगे।
Yes, sir.
अपना कैमरा ऑन करो.
Yeah, all participants are requested to put your camera on. ये लिया आदिल भाई?
Okay. Yeah, am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Okay, great. Okay. So shall I start or 2 more minutes, I guess?
Yeah, Nazma, please introduce our guest.
Okay, sir. Welcome again. Now it's time to call the next resource person, Dr. Surajit Debnath, sir. But before calling upon him, let's have a quick look over his biography. Dr. Debnath currently is the head, Department of Medical Laboratory Technology, Women's Polytechnic, AICTE, Tripura, with more than 13 years of experience in biomedical research and high-level teaching. Dr. Debnath participated in various academic work in institutions of Germany, Denmark, Hancock, besides in premier India labs such as AIMS, IIT Kharagpur, IIT Guwahati, NBPGR. Dr. Debnath is the recipient of Young Scientists Award from different agencies, DBT, DST, and CSIR. Recipient of Tata Trust Grant for CME course in Royal College of Pathologists, London. He is the reviewer of several scopes or SCI index journals published by Elsevier, Springer, Biomed Central. Along with regular academic activities, he's also engaged with several biotechnology companies in Northern and Western India as a consultant. He have conducted various workshops and talks, acted as a session chair in international conferences sponsored by national and international academic agencies. He delivered numerous invited talks in national and international academic gatherings. Currently, he's guiding a group of international students for their internship from Russia, Turkey, and West African countries. Dr. Debnath filed 2 patents in 2020 to 21 in India on biotechnology. Over to you, sir. Over to you, sir.
Okay. So, yeah. So, just hold on. I'll share my screen so that. Okay. Okay. So, since I'll be sharing my screen, I do need some host credentials because only the host can share in the meeting, it seems. I'm getting a notification. coordinator, sir.
Sir, you are now co-host.
Yes, now it is good. Yes, right. I got it. Just 1 second. Okay. No. Yes. Okay. Now let me know whether the screen is visible to you all.
Yes, sir, it is visible.
Sir,
Great.
most probably you have logged in
Okay.
from mobile, so please
what I'll do is,
full screen your mobile.
yes, there was a compatible issue.
Yeah, now it is okay.
Now you check. So what has happened? Thankful to the coordinators for giving me the opportunity to discuss. Myself as a biomedical scientist working in biomedical devices and so on. So we use this data science in a significant way through several modules of artificial intelligence and machine learning. So I hope that our discussion, which may not be a hardcore interest for hardcore computer science, but since the topic of the discussion is application of data science, I hope it will do justice. So having said that, I am again thankful to the AICTE for this sponsoring our lab, for doing this research and development work within our limited means. By saying so, I'd like to start. So it has been seen in couple of years that there has been significant amount of intellectual property in the form of research papers as well as patents, which depends on data science. And it is also not this thing that these are completely what do you call as computer science people. There are an interdisciplinary approach where biomedical scientists along with rest of the other are engaging in application of data science in different areas. So this is the recent trend where there has been significant amount of increase where besides the classical approach, data science is being used by different groups of scientists. So we are also not different from them. Now, what is the advantage? Why people are looking towards it? So the important aspect of these science applications are to reduce the cost of wet lab experiments to a significant extent. So how this is relevant to us? For example, we in our lab try to predict outcome of diseases, for example, cancer and rest of the other things. Now, while doing so, we depend on multiple different tools and techniques in order to reduce the false positive rates as well as false negative rates. So this is how significantly these simulation approach, which largely deploy data science specific tools, help us significantly in smaller labs like us, where the reagents are very costly. We cannot run any wet lab experiment where we are not fully sure. So in order to make an assumption whether we should go ahead with this particular protocol of wet lab, that is by using reagents and so on, we can we use computational simulation to understand whether this would be a good idea or not. So here also you can see that we can differentiate between malignant cancer and benign cancer by using prediction tools. Okay. So here also there is an important aspect that still by using computer science also there are many loopholes where we cannot predict with full confidence. There are some false positives and false negatives. And therefore, what is the this thing then? What is the solution then? The solution is to use multiple different tools in order to get a consensus view. Okay. So by using random forest, by using decision trees and so on. So we'll come to that particular point in couple of slides. So here again, one more important aspect is we are generating huge amount of data. So if I tell about this thing, coordinator sir, my sound is audible, right? There is no problem.
No problem, sir. It is okay.
Okay. So what has happened? We generate a lot of data. For example, we are having tie-ups with all primary, secondary, tertiary care centers or hospitals, where we track for lifestyle diseases, then complicated diseases like various kinds of cancer. We try to find out not the cure, but the prediction on the basis of diagnosis. So there should not be any misdiagnosis. Okay. So while doing so, it is also very important to make the cost very, very low. Otherwise, in country like India, the healthcare cost is very, very high, isn't it? Very, very inflated. So in that case, what the scientific freedom do? So we do generate a lot of data from our these things, what you call collaborators, and we need to have some tools in order to reduce the noise. Okay. Because plenty of the data may not be very significant enough to generate a significant trend line, and therefore we need to reduce those. And therefore we are having collaboration with computer science people also, who write in-house tools and codes which help us to reduce the number of functional or shall I say specific data points from X-ray, from MRI, from blood pressure monitor device, and so on and so forth. Okay. So therefore, I'm giving you the relevance why biomedical science is using data science. Okay. So these are this thing of big data. For example, the cyclotron or quantum mechanics people are generating lot of big data, Similarly, the genomics people, that means biomedical science people, are also generating a lot of data, and therefore we need to have specific tools which will reduce the storage and so many other different things in order to make it very, very what you call is cost effective for all the patients. Okay. So there are some videos as well to show you, to understand what exactly happens when we usually do cancer diagnostics, and later on how we are using computer science to reduce the cost. Okay. So both of these things we will be discussing. Currently, the most important thing in cancer diagnostics is imaging. Okay, image processing and all. I hope all of you are already aware of. So what happens is we take biopsy samples and then eventually look for the region of interest, and on the basis of the differences and from a established what you call is ground data or shall we say training set, we will try to predict what is the stage of the cancer, whether it has become malignant or it is still benign. Okay. So that is one thing. For that also you need to have a lot of data. The data storage is also very costly. So we will not use whatever data we get from the hospitals. We will manually or by means of some automated process, we will reduce the numbers, and then eventually we will put specific slides for making our what you call is a training set, isn't it? So and in this case, we deploy multiple different tools. For example, this would be very much relevant for you. So it has been seen that among all different algorithms, artificial network can support vector machine. Just one second.
Sir, we are unable to hear you. You have muted yourself accidentally.
So kindly unmute yourself. Sir, you're not audible.
Okay, so as you can see here that what? Okay, the screen is visible, coordinator sir.
So it is visible, but you are not audible for some times.
Okay, okay, oh, it may be. So what has happened? These are the recent data which shows that how different algorithms are useful for prediction of cancer. Okay, so as you can see here that the best result is done in artificial neural network and support vector machine. Rest of the other tools or algorithms, shall I say, naive Bayes algorithm. This is again a very important one, and we have seen very good results. Although this does not reflect here. In breast cancer, it gives excellent result, and we will demonstrate a toolbox also, which is based on what do you call probabilistic classifier method or naive Bayes method, which gives excellent result for prediction of cancer in a fraction of the cost. So we will come to that point. So till now, it has been seen that for breast cancer and for prostate cancer and some other cancer also, the artificial neural network has given excellent result, and the other tools are also very similar. Okay, so in this way, it shows that computer science can help us, biomedical science, for prediction of these what we call is different types of cancer to a significant extent. So we'll do a little hands-on also. You may find it very useful later on for your work on if somebody is interested in biomedical discipline. We are also open to collaboration with computer science people. The participants can also discuss if they are having some specific interest. Anyway, so this is a study that has been published in 2020. Excellent result, and it's like now this is the what shall I say is a standard in computer science application in cancer diagnostics. Now here, what the researcher groups have done is tremendous. So why I'm saying so? They have established a protocol where by seeing the biopsy results, they can able to predict how long a patient will survive. Are you getting? So they have not only made it into diagnosis of cancer, they have done it, and they have added some more layers to ultimately predict how long a patient will survive, completely based on convolutional neural network. So I'm not going to discuss the whole this thing, but since we follow their work in a significant way, we are having some collaboration also, and therefore I shared their work. This is not our work, another lab. So how exactly this networking principle works? So all of you are already aware of it. For those who are a bit new in this particular concept, they can also have a what you call as understanding how exactly this thing happens. So let us give you a very good example like this. For example, you are developing a network in order to predict the digit 8. Okay, so what you do, you use a training set which is not exactly digit 8, but it is around, it is somehow similar to the structure of the digit 8. Okay, so whenever you will establish a particular kind of training set, and later on when we will use the sample, the unknown sample, then your network will able to detect that the disease, the digit that you are showing, the pixels are arranged in such a way that it is can able to predict the digit 8. Okay, out of n number of different digits. But there is a problem. The problem is it can also misdiagnose the whole thing, and therefore just one second. So yes. Okay. So it can also give you a wrong prediction if you giving the digit 0. So this is the problem here. So how biomedical scientists can do something so that there is no scope of any kind of error. Okay, because cancer diagnosis is a very crucial thing. You cannot say some person with some fuzzy logic. Okay, there is no space for it. So if you say that 30% probability that you are suffering from this disease, this is not done. You cannot say like this. It should be 0 or 1. Okay, so what we are proposing is to produce one more layer which is based on genomics. Now genomics, if I say, it will become a bit difficult to understand for hardcore computer science people. It is nothing but to analyze the programs that are already there in human body. All human bodies are having the structural unit or functional unit of human body is a single cell. Inside the cell, there is a thing called DNA. So I think multiple usage of DNA you are aware of already, although you may not be from this background. So in DNA, there are specific programs which will assure that which kind of disease you will get at which kind of age. We till now we have not yet deciphered the whole paradox, but it is written there. Okay, so we are about to explore those things. So I'll give you an idea so that you can understand how genomics and computer science are complementing each other to get excellent results. Okay, so here you see. It was a kind of brain tumor which was been diagnosed, and the neural network along with genomics has given so tremendous result. They can predict how long, even 775 days, 3056 days, like this they can predict. Okay, exact date, how long the patient will survive. Okay, so how did they do this? They have added one more layer which is of genomics, and therefore the wrong prediction ability has been diminished to a significant extent. So we'll do a little hands-on now. So may I request our coordinator to share the first video quickly so that we can just give our participants an idea what exactly happens today during diagnosis of cancer. Okay, and later on we will do a little hands-on which will give us an idea that what exactly happens these days, how we can reduce the cost of this whole exercise to a significant extent. So here you see, here what they have done is they have not used the image processing. Along with that, they have also used the DNA program which is already there in the patient. Okay, so we are using two things: one, image processing of the biopsy sample, and then using the genomics, that is the inbuilt programs which are there in each and every cell of human being. Okay. So okay, now the what is the ultimate goal? The ultimate goal is personalized medicine. Okay, now today what happens is a single kind of medicine is given to everybody, and therefore we see very different kinds of outcome. For somebody the medicine works excellently, for some people the medicine is no difference at all, but in some people it becomes very dangerous. Okay, the application of medicine. So this is today's scenario. But what will be the future of the medicine? Future of the medicine will be such that everybody will have optimum outcome, and therefore we will design the medicine in such a way that it becomes optimum. Okay, so today data science is giving us a platform where we can think about it, talk about it, and also practice personalized medicine to some extent. Okay, so okay. Okay, this is a pipeline where we decipher the internal program that is present in each and every human being. Okay, each and every cell of human being is nothing but a program which is written in quadruplet codes. ठीक है, आपका जो machine का language है 0 and 1 का binary codes. So we are having quadruplet codes, 4 different coding this thing. And what it makes is, what is the use? The use is that in a small space we can code for very complex things. Okay. So this is the pipeline where we are deciphering the what you call is the genomic data which is present in every individual. Okay, we are not discussing it, although we deploy a lot of computer science people, even people from BTech also, they are collaborating with us, but our students only. So this is the database where all the programs of human beings, that is DNA level programs, are written and submitted. It's a dynamic database where the servers is present in the Maryland, USA, which is run by what we call is NIH, National Institute of Health, USA. And this is a real-time database, and we can use this database free of cost to explore what we call genomic programs, okay, genetic programs which are already been written in every human body. Okay, so we will do a little hands-on and see the video so that it gives you a better context. So may I request our coordinator to play the first video and subsequently enter into the first simulation, which will give us an idea what exactly happens during prediction of cancer by using small toolbox. Okay. So coordinator, please share the video in a mute condition.
Naseem sir, can you please give me privileges of sharing my screen?
Okay, okay. So I'm stopping my share. Okay, I have stopped sharing.
Naseem sir, are you there?
Naved, I will make you co-host.
Okay.
Now you are co-host.
Okay.
You can.
So here, okay, fine, great. So in this video, we'll just share with you, with the participants, that what exactly happens today. Okay.
Sir, is it visible?
Okay, fine. हाँ सही है एकदम सही, आप चला दीजिए, फुल स्क्रीन पे चला दीजिएगा और मतलब म्यूट करके चलाइएगा. हाँ चला दीजिए, ठीक ठीक ठीक. Okay, this is called the biopsy sample. Okay, this is nothing which is a sample taken from the cancer tissue. Okay, then we will make it into small pieces and observe under microscope. Okay, by putting some stain so that it becomes visible, and then under the microscope we will see what is the stage of the cancer. Now this is the today's procedure. Now here आपको लगेगा कि problem क्या है? Problem ये है कि इसका diagnosis is very costly. Why it is very costly? Because it needs human intelligence, and you know human intelligence is much costlier than machine intelligence. Okay, now human intelligence का और एक problem है, उसका क्या है? Repetitive जो task होता है, anything that is repetitive, it becomes monotonous for human intelligence and therefore it can go wrong. Okay, कभी-कभी ऐसा होता है, एक stage है, वो दूसरा ही stage में आपका prediction हो जाता है. Okay, I do not know how you can able to this thing correlate the whole process, but this thing is true. So in order to reduce this chance, we are depending on computer science. Okay, now in computer science what happens, as I have said, that the what do you call is the genomic DNA is isolated and the program is deciphered. So I'll be requesting our coordinator to mute the rest of the people. Okay, now here you see TGCA. These are the 4 codes through which the program is written in human body. Okay, so in the human body it is written in detail that whether he will get a cancer or not. Okay, so here we are trying to establish a link between the existing method and the what do you call data science method. Okay. Okay, thank you. So next I'll be requesting you to play the, not play, one simulation is there. Please see simulation 1, something is written there. So you click on that and still share your what do you call desktop. Okay. So we'll do a little hands-on, which will give you some idea that what exactly happens. देखिए email में simulation 1 बोल के कुछ होगा.
Is it a video file?
Video अभी थोड़ा. No, it is not a video file. It is just a HTML text. If you click on it, you will enter into the database.
Okay. Okay.
देखिए simulation बोल के एक है, देखिएगा simulation 1 बोल के एक है, वीडियो नहीं है. तो और एक प्रॉब्लम क्या है, हमारा जो इंस्टीट्यूट में जो है, हमारा जो सब्सक्रिप्शन है किसी और मतलब प्लेटफॉर्म का है, तो कभी कभी क्या होता है, नहीं ये वाला, हाँ ये वाला, यस यस, ओके। सो यहाँ पे क्या है, ये जो है आपको जो शेयर किया गया है, सो इट इज नथिंग बट ए होल जीनोम सीक्वेंस ऑफ ए पर्टिकुलर बैक्टीरिया। ठीक है, थोड़ा अगर आप नीचे जाएंगे, थोड़ा स्क्रॉल डाउन कीजिए सर, तो थोड़ा नीचे जाएंगे वो तो सबको दिखेगा कि हाउ द जीनोमिक डेटाबेस इज मेंटेन। सो दे हैव रिटन सो मेनी इंफॉर्मेशंस हियर, इट इज नथिंग बट ए होल जीनोम, दैट मींस पूरा एक बहुत ही स्मॉल ऑर्गेनिज्म है जिसको मतलब माइक्रोस्कोप के अंदर ही देखा जाता है, जिसको बोलते हैं बैक्टीरिया। वो क्या करता है, बहुत सारा डिजीज कॉज करता है। ठीक है, ओके। सो दिस इज द डेटाबेस ऑफ द होल जीनोम, द फुल बॉडी में। सो होल जीनोम का क्या है, इट्स अ ह्यूज अमाउंट ऑफ डेटा, but some part of data only indicates whether a patient will get a cancer or not. So what happens, हम क्या करते हैं, जब हमारे पास बहुत सारा डेटा होता है तो हम क्या करते हैं, पूरा डेटा को जो है थोड़ा थोड़ा स्मॉल स्मॉल पार्ट में सेगमेंट करके रखते हैं। तो ह्यूमन बॉडी का अंदर में भी पूरा जो डेटा है उसको क्या करते हैं, डिफरेंट डिफरेंट एरिया में, डिफरेंट डिफरेंट लोकेशन में उसको सेव करके रखा जाता है। तो एक एक लोकेशन का नाम होता है क्रोमोसोम। Okay, although it is not very relevant, but I'm just giving you a context. So यहाँ पे भी ये है, ये पूरा जीनोम है, बहुत सारा डेटा, लेकिन हमको क्या है, पूरा डेटा नहीं चाहिए, थोड़ा बहुत ही डेटा चाहिए जिसमें हमको दिखेगा कि whether the patient will develop a cancer or not. उसका कुछ भी बायोप्सी का रिजल्ट हो, ultimately he will die or not die, it's all written in the genes. So इसमें क्या है, पूरा बुक पढ़ने का जरूरत नहीं है, उसका जहाँ पे हमारा रिक्वायरमेंट है वो पेज ही हमको चाहिए। सोचिए कि होल जीनोम क्या है, इज नथिंग बट ए बुक, फ्रॉम दैट बुक ओनली सम पेजेस आर इंटरेस्टिंग और सम पेजेस आर रिलेवेंट, इजंट इट? सो बहुत सारा नॉइज है, तो नॉइज को आप हटा दीजिए, तभी आपका क्या है, डेटा जो है मैन्युअली और ऑटोमेटिकली क्यूरेटेड हो जाएगा। सो सिमिलरली वी विल डू, सो आई विल रिक्वेस्ट यू टू गो टू द नेक्स्ट विंडो, यू हैव ऑलरेडी ओपनड इट, नेक्स्ट विंडो यू कैन सी BRCA इज रिटन। सो हाँ, यहाँ पे क्लिक कर दीजिए, हाँ वहीं पे BRCA लिखा है, देखिए। हाँ, सो इन द प्रीवियस पेज हमने आपको क्या दिखाया, होल जीनोम दिखाया, बहुत सारा डेटा। तो इतना डेटा तो हमको चाहिए नहीं, वो एक बैक्टीरिया का है, तो सोचिए ह्यूमन का और भी बहुत सारा होगा। ठीक है, सो हमने क्या किया है, एक पर्टिकुलर सेगमेंट को मतलब सेपरेट कर दिया पूरा जीनोम से, तो उसको क्या बोलते हैं, उसको बोलते हैं BRCA। अभी देखिए लिखा है यहाँ पे BRCA, देखिए। So BRCA is nothing but a program which is written in human body which ensures whether a person will get breast cancer or not. Okay. So BRCA program is a program which ensures or which determines whether a patient will get a breast cancer or not. Only for breast cancer. So what does it mean? Different cancer के लिए different program है human body में. ठीक है. So now what is our job? Our job is to find out whether a patient जो है उसका जो प्रोग्राम है, इनबिल्ट प्रोग्राम जो है, उसमें क्या खराबी है। अगर कुछ खराबी है तो वो खराबी ऐसा है कि वो कैंसर को लीड करेगा कि नहीं। ठीक है, ये देखना कंप्यूटर साइंस का काम है। तो क्या होगा, सो देयर शुड बी सम व्हाट यू कॉल एल्गोरिथम व्हिच विल एबल टू डिटेक्ट इफ समथिंग हैज रॉन्ग इन द प्रोग्राम। सो हमें ये कैसे करते हैं, हमारे पास एक स्टैंडर्ड प्रोग्राम होना चाहिए एंड वी हैव टू रन दैट प्रोग्राम। Okay, and if there are some error, the program will not run. It will give you no what you call executable step, and eventually it will not get completely executed, isn't it? So computer science can predict whether the program is good or not. So remember that we are talking about a program which is present inside the human cell. It's not in CD, or it is not in a hard disk or something. Okay, so what is the task? The task is to decipher the program from that quadruplet codes, okay, that you saw, and then to run into the software which will help us to understand whether the program is false, or program is executable, or program is with error. If error is there, then what will happen? There will be definitely cancer, whether your biopsy sample says it or not says it. So I'll give you a specific example of a person, very famous person, Angelina Jolie. I hope many of you have heard this lady's name. She is a very famous actress of Hollywood. Now she had a problem with her genes. What was the problem? The problem is that all her maternal her I'm talking about like 10 years back. So what happened, since she understood that there is something wrong in the gene, she has talked to the very good doctors in USA. They said that there is only one way out, whether you'll know whether you'll get the cancer or not, is to do a genomic study. So at that period of time, genomics was not very common. So what she did, she given a particular kind of donation to Harvard University genetics department, and the genetics department developed a program from which we can now predict very nicely, very simply. We will do that demonstration today. Demonstration today to show you that how on the basis of these what do you call prediction tools we can able to zero in with a foolproof prediction without any what do you call error. Okay, so now I'll. So you understood two databases we have shown. One is the whole genome thing, ठीक है, ह्यूमन का भी है, वो बैक्टीरिया का दिखाया क्योंकि वो लोड होना इजी होता है, ह्यूमन का होने से it will take longer time to load because so much of data. So now we have also shared with you one more data of the BRCA program. Now BRCA program is what? It's a small program which ensures that a person will get a cancer or not. Okay, and we are also having a tool which will help us to understand whether this program is good or bad for different people. Okay, so we'll get back to our presentation again, and then we'll again discuss that how exactly what is the relevance. Okay, so okay. Okay, so this is how we decipher. We take blood sample from the patient and then put it into a what we call a whole genome sequencer, which will sequence the data. The abhi, matlab now also, because due to the COVID, many of you are already aware of this kind of technology where you do RT-PCR, isn't it? You have heard about RT-PCR, this and that. So RT-PCR is also a method through which we do genome sequencing. Okay, whether the particular kind of DNA is present or not present, on that basis we can decipher that if if a particular kind of DNA is present in a sample or not. So it is somehow similar but very more complicated than RT-PCR. So okay, now this was the database that we showed. This is the whole genome, human genome, okay, which will take a lot of time to load. So we have not shared here. So this is the whole genome of human being. Okay, so this is an unmutated standard version of a human being which is written in that, which is present in the database. In a database, complete human genome is opened and deciphered and given for all kinds of study if somebody is interested. Now this is the BRCA gene product or BRCA program, which is a part of the whole genome and which determines whether a person will get a particular kind of cancer or not. Now going to the what do you call toolbox. Okay, so we shall see what exactly. Okay, this is the clinical outcome prediction pipeline. I will not go to the details of it. It is also a kind of small algorithm, and different part executes different what do you call activities, and ultimately we come up with the prediction. Okay, so I hope you can feel about the reason of the whole exercise is to reduce the cost by collaborating with biomedicine and what you call computer science. Now this is the toolbox we were talking about. Okay, now this is using a particular algorithm which is called probabilistic classifier. Now in probabilistic classifier, what happens? In probabilistic classifier, we are able to predict an outcome on the basis of three things. Now here you see posterior event. Posterior event means our prediction. So our prediction is based on what? Prior experience, हमारा पहला का जो एक्सपीरियंस है, उसके बाद जो है उसका likelihood, it's a quantitative probability, likelihood, and then the evidence. Okay, so you can understand that machine learning is not very different from human learning also, isn't it? So on the basis of your prior experience only you decide whether you will take certain decisions or not, isn't it? So similarly, probabilistic classifier or naive Bayes algorithm will help us to understand on the basis of a prior experience as well as evidence whether a particular kind of what do you call program is leading to a cancer or not. Okay. So what exactly happens is coordinator sir, वो आप म्यूट कर दीजिए बाकियों को.
This is now muted.
So now here you see. Now here what you see in naive Bayes algorithm also there are some benefits and there are some limitations, isn't it? It also can go wrong. It can also give you wrong predictions. So how you will reduce the number of false positives or false negatives? You generate more sensitive database or sensitive what we call training set. So today we'll use a toolbox which in background runs a Python script which filters huge amount of data on cancer, not only breast cancer, all kinds of cancer, which is taking place in UK. And now they are also collaborating with India. So India में जब भी कोई patient का DNA sequence दिखता है जिस जहाँ पे cancer होगा, instantly the data is shared with this Harvard University server, and the Harvard University server is enriched, and its algorithm becomes more and more stringent with every day. But this is how the intelligence is developing, isn't it? So it is also like the other networking sites and so on. They also generate intelligence on the basis of whatever data you input, isn't it? So similarly here, this particular toolbox, which runs as Python script and which basically uses the mainframe computer of Harvard University. We shall just look into it. So, okay, before going there, in 2014, we started using computer science for biomedical research, and we received some small grants from international agencies. This was our first work where we predicted the case of a heart disease on the basis of computer science and computational prediction. So today, this particular paper, which was generated by our lab, is a shall I say showcase paper of that particular group, which is called Parth Syndrome Foundation. It's a genetic disease where patient will die due to heart abnormality within 14 years of age. Anyway, so these are more prediction tools which are in use. I'm sure you are already aware of it. This is again a support vector machine based tool. So for COVID research, for vaccine development, SBM has given tremendous result. So before going to this, we'll again tell our coordinator to again share his screen within those windows which you have already opened. So मैं अभी अनशेयर कर रहा हूँ, आपका स्क्रीन जो है आप शेयर कर दीजिए. हाँ, आपका जो स्क्रीन है वो आप शेयर कर दीजिए. तो हम अभी क्या करेंगे, एक छोटा सा एक्सरसाइज कर लेंगे. So I hope all our participants has also received the links. So yes, so please coordinator, आप ये जो genetics Harvard वाला link है, इसको आप टूल चैट बॉक्स में शेयर कर दीजिए, तो ये पार्टिसिपेंट भी कर पाएंगे. ओके, और ये कर दीजिए, और BRCA वाला प्रोग्राम का जो HTML लिंक है उसको भी आप शेयर कर दीजिए. ठीक है, ये दो वाला जो चीज है आप शेयर कर दीजिए. पार्टिसिपेंट्स अगर चाहें तो वो इसको यूज कर सकते हैं. ठीक है. नाउ दिस टूल बॉक्स पॉलीफेन 2 is hosted by Harvard University mainframe computer system, which is also known as grid computer, means where you can access the computational tool without downloading the software. So here what happens, you are not using your own computational resources, but you are using the computational resources of that university. Only you are using your internet, okay, through a remote server, something like email. You put an attachment in your email. You need not to store the same document in your hard drive. It remains stored in the cloud. Whenever you want, you can access that, isn't it? So similar kind of thing is also happening here. If you want, you can download it, but there is no point, because you cannot able to download. You need a NVIDIA workstation kind of thing with 100,000 TB of storage space. So it becomes a monotonous thing. So this is the window, and now we will do the hands-on. Okay, sir, please go to the BRCA program page. BRCA program page पे चले जाइए. BRCA देखिए ऊपर है, उसमें आप चले जाइए. So BRCA program is a small program which is present where inside the database, which is again an HTML link only, nothing more than that. But the server is present in NIH, National Institute of Health, Maryland, USA. So this is the BRCA program. So as you can hear also, you see so much of information is there, which is not very needed for to run the simulation. So what we'll do, we'll convert the program into a more usable format. Okay. So we'll do the format change here itself. तो आप थोड़ा ऊपर चले जाइए, ये पेज को थोड़ा स्क्रॉल आप कीजिए तो यू विल गो टू द टॉप. हाँ, वो स्क्रॉल करके ऊपर चले जाइए, स्क्रॉल कीजिए, स्क्रॉल कीजिए, स्क्रॉल करके ऊपर चले जाइए.
Sir, is it fine?
हाँ, तो अभी देखिए, हाँ, that is absolutely fine. So here you see on the bottom, just after the BRCA written there, no, FASTA is there. Can you see FASTA? Again, hyperlink. Just this one. FASTA. Can you see? Yeah. You click on this. FASTA. Faster. You click on this. Click कीजिए. Now what will happen? The format will change. Have you clicked it?
Yes, sir.
Once again, you please click on FASTA. FASTA. Okay. Great. So what has happened? The format has been changed. Previously, there was so much of unwanted information. Now we are having the sequence. Okay. Now this is the program written in very simple, what you call understandable language. Okay. Although it is not the same, which is also already present in the human body, inside the human body, we have converted it into a understandable high-level language, let us say. Okay. So this is the BRCA program of human being. Homo sapiens means human being. ठीक है. तो this is the unaltered program. मतलब कौन सा वाला प्रोग्राम जो अच्छे से एग्जीक्यूट होगा. तो हमको अभी इसको कंपेयर करना है किससे? एंजेलिना जूली का जो है उनका डीएनए से, उनका जो सैंपल है उससे हम उसको कंपेयर करेंगे बहुत ही जल्दी, बहुत ही सिंपली, and by using the toolbox developed by genetics department of Harvard. So now what we'll do is we'll copy the whole sequence. Sir, आप जो है वो ग्रेटर देन साइन से पूरा जो है सिर्फ ग्रेटर देन साइन देखिए. हाँ, यहाँ से जो है डिजिट के देखिए नीचे है. हाँ, इंक्लूडिंग द ग्रेटर देन साइन, इंक्लूडिंग द ग्रेटर देन साइन जो है आप इसको कॉपी कर लीजिए. हाँ, कॉपी कर लीजिए.
ओके.
हाँ, अभी आप जो है उसमें चले जाइए, तो टूल बॉक्स में चले जाइए, पॉलीफेन 2. ठीक. अभी हम क्या करेंगे? We will do a little simulation just by editing the text. Okay. So now we will paste this sequence in the second window. अभी देखिए एक second window है, protein sequence in FASTA बोल, उसमें आप उसको जो है पेस्ट कर दीजिए. हाँ, कंट्रोल V कर दीजिए. चलिए ठीक है, पेस्ट कर दीजिए आप. So ये जो है हमने क्या किया है, ये अनअल्टर्ड, मतलब जिसको भी ब्रेस्ट कैंसर नहीं है उसका जो है डीएनए का जो सीक्वेंस है इस तरह से दिखता है. ठीक है. जिस किसी को भी जिसको मतलब who somebody has died but not due to breast cancer, everybody is having this kind of program which is executes nicely and eventually the person never gets a cancer in breast. Okay. But we are now interested in the outcome of that lady Angelina Jolie. Okay. Now we'll see what happens to her. So we now in the second, there is a next window, position window. Can you see? In the position window, you write the digit 8. Okay. You write the digit 8. हाँ, बस काफी है. Now what is this? It is nothing but the mutation. Mutation तो अभी हर किसी को मालूम है. What is mutation, isn't it? Due to the COVID, everybody now knows about it. What is this? It is nothing but a change in the DNA or RNA. In COVID case, it is an RNA because the COVID itself is a RNA virus, and therefore whatever mutation takes place, alpha variant हो गया, delta variant हो गया. आपने सिंगापुर गया, सिंगापुर जाने के बाद इस तरह से आपको कोविड लेने के बाद भी कुछ काम नहीं करता. ठीक है. ओमिक्रॉन हो गया, कुछ हो गया. तो what are those? These are nothing but the mutants. Now this lady is also having a mutation where on the 8th digit of the program. ठीक है. जैसे क्या कोई लाइब्रेरी फंक्शन आपने ठीक से नहीं किया तो क्या होगा? प्रोग्राम रन नहीं करना. Similar case with this lady. So in that lady, the 8th amino acid और 8th digit जो है वो चेंज हो गया. देखिए कितना लंबा स्ट्रिंग है, इसमें सिर्फ एक डिजिट चेंज होने से क्या होता है, पूरा प्रोग्राम जो है कोलैप्स हो जाता है. So if you are having the genomic information of a single person, then you can easily detect it, isn't it? अभी आपका क्या है, उनका बायोप्सी करने का भी जरूरत नहीं. इन्होंने तो बायोप्सी करवाया नहीं, वो क्या किया, अपना होल जीनोम का सीक्वेंस करने को बोल दिया, क्योंकि उनके पास बहुत सारा is having so much of money and therefore she can afford the whole genetics department. मतलब 50 different scientists, ठीक है, top level scientists, they have executed her work. I'm talking about 10 years back. Anyway, so what happened? 8th amino acid, चलिए देखते हैं क्या है. L से शुरू होता है, देखिए LTKDRM. तो 8th amino acid क्या होता है? 1 2 3 1 2 3 4 5 6 7 8. What is the 8th amino acid? I think it is V, no? Let's once again see 1 2 3 4 5 6 7 8. Right, absolutely. So valine, V is there. So अभी क्या करेंगे हम? AA1 में जाएंगे और V को क्लिक करेंगे. AA1 का विंडो में जाइए, हो गया. नीचे आ जाइए, V देखिए किधर है, लास्ट में है, लास्ट में V है, V को क्लिक कर दीजिए. हाँ, अब इनका क्या है? इनका जो है P में क्लिक कर दीजिए. हाँ, यहाँ पे क्लिक कीजिए, ये सिलेक्ट हो जाएगा.
Sir, already
सिलेक्ट हो गया.
it may,
तो अभी
it
क्या
may be
है?
a bit late on your side.
Fine, fine, great.
Okay.
No problem, no problem. Yeah, yeah. So what happened? You have selected the V because you know. हम कैसे जानते हैं? Research paper से जानते हैं कि this lady is having this kind of mutation. Okay. Nowadays you can also know about you because it the cost has significantly reduced. Okay. If you go to the tertiary main hospital in Jammu or in Srinagar itself, you can also give your sample to the genomic medicine people. I'm sure there is a department there also, and you can done away with your sequencing. But in previously it was not very easy. Today it is easy. If you have some money, 40,000-50,000 rupees, you can get it done. So now, what is the substitution of this lady? So her V has been replaced by R. Okay, चलिए आप ये करते हैं simulation. AA2 में चले जाते हैं. AA2. Here you click on R. You click on R, aspartic acid. R देखिए है, थोड़ा सामने चले जाइए. हाँ, सामने चले जाइए. हाँ, देखिए R है, A के बाद ही है R.
Done, sir.
ठीक है, R में क्लिक कर दिया. हाँ, बहुत बढ़िया. तो हमने यहाँ पे किया क्या? हम जानते हैं from published research that a particular person is having, let it be somebody, anybody, is having a change in the program where a single digit has been replaced. इसको बोलते हैं SNP, single nucleotide polymorphism, और बोलते हैं mutation. Mutation तो हम सब जानते हैं these days, thanks to COVID pandemic. Now we will submit the query. Very, very simple to do. Anybody can do it if you know your mutation. Okay. So we'll submit the query. You submit the query. Okay. And now the algorithm will start. Okay. And we are entering into grid gateway interface of Harvard University. Okay. So it is calculating now. The load is high. So many people are working on this particular tool because it is free. No, anybody can use it. Isn't it? So many people are doing different. किसी का कुछ भी mutation जो है, सब कुछ you can able to understand from this. Okay. Now you once again refresh, एक बार press कर दीजिए. वो विंडो में रिफ्रेश नहीं कीजिए, यहाँ पे जो रिफ्रेश दिया गया है बटन, उसको एक बार दबा दीजिए. हाँ, तो थोड़ा ये मतलब ये करेगा. हाँ. यस. यार यू क्लिक. ओके, रिजल्ट आ गया. देखिए बहुत ही जल्दी. We'll come back and we'll see how big the database was. I can tell you. जैसे कि सोचिए कि श्रीनगर मेडिकल कॉलेज में एक ब्रेस्ट कैंसर का पेशेंट आया, तो डॉक्टर क्या किया? उसका सीक्वेंसिंग किया. सीक्वेंसिंग से उसको एक म्यूटेशन का पता चला. ठीक है, वो डायरेक्टली मतलब वो क्या करेगा? बहुत ही जल्दी एक ईमेल भेजेगा. कहाँ पे? हार्वर्ड यूनिवर्सिटी जेनेटिक्स डिपार्टमेंट. वो लोग क्या करेगा? ये इसका जो डेटा है उनका डेटाबेस में डाल देगा. Every day, every second, the database is increasing. So learning is enhancing and the prediction is also getting stronger day by day. So now we'll see the result. So result के अंदर में आपका देखिए ब्लू कलर का हाइपरलिंक, उसमें आप क्लिक कर दीजिए. हाँ, इसमें थोड़ा एरर है, उसको अवॉइड करेंगे. ओके, तो अभी आएगा आपका रिजल्ट. हाँ, चलिए आ जाएगा. हाँ, देखिए, so nicely within a minute you are getting it. You are getting the result. And what is the result? Just 1 second. So what is the result? The result is damaging. Okay. The result is damaging. Why it is? Now there are some probability also. Here you see sensitivity 0, 0, specificity 1. मतलब क्या? 100%. the lady will have this kind of life-threatening condition, and therefore this lady has got operated the tissue, and since she is an actress, she is using a prosthesis. Okay? Because she, मतलब आपको क्या है? If you survive, you should get rid of that particular tissue. Okay? And then only you can survive. So she did the same thing, and this was the first study where computer science naive Bayes algorithm has been used with 100% accuracy that day. 10 साल पहले का जो database है, अभी तो बहुत ही ज़्यादा high हो गया इसका. Everybody is using, all kind of people. That is also for free. No download, nothing. Only by click of a button. Okay. So this shows how. And now, if you want to do the with more significant stringent study, so what you will do? You will do the biopsy sample, put it in the toolbox that we have developed, and eventually you can be 100% sure. Okay, since it is there, they are giving it excellent result, but everybody's mutation is not like that. किसी का कुछ और mutation हो सकता है, where the result will be fuzzy. ठीक है, मतलब probability 50-50 हो गया. इसका तो कोई use नहीं है. So what you do? You also use image informatics. Okay, and then you come to this thing, what you call as prediction. Okay, so this is how this big data is helping us to understand, mainly to reduce the cost of the medicine. Okay, so I'm not sure whether time is permissible or not, and people are still interested or not. There is one more part that I am interested in, to talk about the vaccine design protocol, how we are using computer science. By visual thing only, not in coding and things like that. People have done excellent coding all these days. So now we can use, we can able to deploy those tools to make you understand that how vaccines are designed, and what is the main what do you call ingredient in the vaccine, and what are the shall I say quality control measures that we look into while designing the vaccine. So the coordinator should tell me whether I should go ahead or I should conclude my discussion.
Sir, you are giving the excellent lecture on these topics. So means I would like to continue this particular lecture. Please continue, sir.
Okay. With your kind permission. Fine. So what exactly happens is, yes. So what exactly happens is, we'll this is for the cancer diagnostics. Okay, so in our lab we are talking to people, we are collaborating with multiple different, what do you call is okay, we are talking to we are collaborating actively, and we are still looking forward to people who are interested in handling our large data, because we are getting so much of data now every day, and we are not very good with computer science, and therefore we require people and we can assure one thing, that we will definitely able to generate good amount of intellectual property in the form of research papers initially, and eventually we can also do away with patents, and we are also hopeful to monetize those things also as per government norms. Okay, so there are other these things also in vaccine design. Okay, this is the whole this thing, that how the integration is taking place. Okay, support vector machine, artificial neural network, different use of different what do you call algorithms, and ultimately it gives us an idea. Okay, it gives us an idea that how we can integrate between different expertise. हमारा जो expertise है पूरा DNA analysis, उसके बाद to identify the mutations, and then eventually helping you with the database. But computer science people are needed to generate the algorithms and to run them successfully, so that the prediction is done with 100% accuracy. So yes, so this is the COVID infection system. Okay, so we all are already we already know about it. So here what happens is, The COVID virus is such virus, all of you know. So on the surface of the virus, there are small spike proteins. Spike मतलब क्या? Lock and key मतलब. उसका body में जो है key है बहुत सारा, ठीक है? वो key जो है वो lock को ढूंढता रहता है. वो lock जो है, lock किधर है? Lock है आपका respiratory tract में, आपका lungs के अंदर एक receptor है जिसको बोलता है ACE2 receptor, ACE receptor, ठीक है? So ACE2 receptor has compatibility with the क्या? जो spike protein है, ठीक है? तो you everybody already know about it, the structure of the COVID virus. Everybody knows about it. So what happens whenever this COVID virus enter into the respiratory tract? अगर आपका मुंह से अंदर जाता है कोई दिक्कत नहीं. सोचिए कि ऐसा है कि मतलब आप मास्क नहीं पहना है तो अभी कैसे सांस लेगा? मुंह से सांस लेगा. नाक को पूरा बंद कर लीजिए, मुंह से सांस लेते रहिए, आपको कभी नहीं होगा. So it is very strange, you know, people will be saying कि आइस से अंदर जाता है, fine, but मुंह से नहीं जाएगा. मुंह से क्यों नहीं जाएगा? Because if your glottis, वो जो अंदर में जो है वो अगर if it is closed nicely, if you take oral inhalation of air, so you will not find that receptor. Receptor is present where? Through nasal cavity. Okay. So therefore what will happen? The virus will enter into your stomach, and inside the stomach so much of acid is there, hydrochloric acid, so many acids, it will digest the virus. So it will not able to make you sick. Okay. But in the nose, nasal cavity, the receptor is present. एक भी अगर अंदर जाता है, if a single bacteria virus enters, there is a probability that it will bind with the receptor, क्योंकि lock जो है वो तो किसको खोजेगा? ताला को खोजेगा, key को खोजेगा. So when lock and key are in close proximity, what will happen? The lock will open, isn't it? So similar thing happens. So what is the function of the vaccine? Vaccine is nothing but a small part of the virus itself in different ways. Okay. कोवैक्सीन और कोविशील्ड जो है, जो हमारे एज ग्रुप का है, उन्होंने शायद कोविशील्ड नहीं कोविशील्ड लगाया होगा, और जो नेक्स्ट जनरेशन के हैं वो उन्होंने कोवैक्सीन लगाया होगा. तो ऑल कोवैक्सीन एंड कोविशील्ड इज मेड अप ऑफ द सेम थिंग ऑफ द वायरस, दैट इज द वायरस इटसेल्फ, बट इन अ फॉर्म वेयर इट इज नॉट एबल टू प्रोड्यूस द डिजीज, बट व्हाट इट इज एबल टू जनरेट इम्यूनिटी इनसाइड यू, ताकि ऐसा पता चले कि जब भी रियल में जब भी एक वायरस आपके अंदर जाएगा तब आपका बॉडी का जो इम्यून सिस्टम है, ठीक है, वो इंस्टेंटली उसको रिकॉग्नाइज करेगा और उसको एलिमिनेट करेगा. वेरी सिंपल. इफ यू नो योर enemy, it is easy to eliminate it, isn't it? So this is also the same thing. Now the interesting thing is, वायरस का जो स्पाइक प्रोटीन है, आपने अगर देखा होगा उसका स्ट्रक्चर, बहुत सारा स्पाइक प्रोटीन. तो कौन सा वाला स्पाइक को आप जो है वैक्सीन का माफिक यूज करेगा? पूरा को तो नहीं कर सकता है क्योंकि इट्स ए ह्यूज मॉलिक्यूल, एंड सो व्हाट विल हैपन, वो जो आपका जो सोल्यूशन बनेगा वो बहुत ही डेंस हो जाएगा और आपका बॉडी के अंदर जाएगा नहीं ठीक से. So you need to make it low molecular weight. उसका जो weight है वो कम होना चाहिए. तो क्या करिएगा, आपका बहुत सारा स्पाइक प्रोटीन है, उससे एक पार्ट को आप सिलेक्ट कीजिएगा. तो ये जो सिलेक्शन है, that we can do with the help of computer science, because we are having the three-dimensional, what you call coordinate, structural coordinate of the whole virus. We will show you. And out of the whole 3D structure, we have to find out a single structure which is very stable. ठीक है. क्या चाहिए आपको? एक स्टेबल चाहिए स्ट्रक्चर जो अंदर जाने के बाद भी जिंदा रहे, क्योंकि क्या होगा, आपका ब्लड में तो बहुत सारा चीज है. आपका ब्लड के अंदर क्या क्या है? सॉल्ट है, ग्लूकोज है, बहुत सारा चीज है ब्लड के अंदर, ठीक है. तो आप जब वैक्सीन लीजिएगा, वैक्सीन विल कम इनटू कांटेक्ट विद सो मेनी डिफरेंट थिंग्स. सो व्हाट कैन हैपन इज द वैक्सीन में बिकम डिग्रेडेड, क्योंकि आपका ब्लड में बहुत सारा सोडियम क्लोराइड है, बहुत सारा डिफरेंट तरह का जो है आयंस है, बहुत सारा डिफरेंट इंटरेक्शंस है. सो यू नीड टू फाइंड आउट अ स्ट्रेटेजी वेयर you will not insert the real COVID virus itself, but a small part of it that also very stable. So in order to do that identification of stable part of the whole virus, computer science will help. So you'll see how exactly it happens. Okay, so I'll not go to much detail. Okay, in 2020 we reported a study by seeing that different people are having different this thing by using computer science only to a large extent. We published this paper, and this is a hallmark paper in WHO. If you can go there, If you can go into WHO website and you write about this particular paper, you will see this study. Okay, it is also been this thing in WHO website. So what is the idea behind it? The idea behind it is to identify a very stable epitope on the surface of the COVID virus. Okay, क्योंकि पूरा COVID का तो आप ले नहीं सकते हो, so क्या होगा, वो जो इंजेक्शन जो होगा वो लिक्विड नहीं रहेगा, वो सेमी सॉलिड हो जाएगा और बहुत सारा डेंसिटी बहुत बढ़ जाएगा because it's a high molecular weight virus. ठीक है, so you have to make it low molecular weight at the same time stable. Stable मतलब क्या, ब्लड के अंदर जाने के बाद भी उसका इंटैक्टनेस रहना चाहिए. ठीक है, ताकि वैक्सीन काम करे, वरना क्या होगा, वैक्सीन काम नहीं करेगा. वैक्सीन तो आपने ले लिया, काम नहीं करता, बूस्टर डोज देना पड़ेगा एवरी मंथ. Here also it is the true, you have taken 2 booster, isn't it? 1 booster dose you have taken, and now who are 60 plus years, for example my mother should be taking 1 more booster dose on the month of April. So similarly, those who are more than 60 years, you have to once again take a booster dose. Why? Because your immunity is already low, and in order to regenerate your immunity, you should take a booster dose. Okay, now this is the virus database. In this virus database, we are having the structural detail of the COVID virus. Okay, this is also free of cost. This is again housed in a what you call database maintained in USA, and anyone can use this. Okay, so here is this thing. This is the here you can see severe acute respiratory syndrome coronavirus 2 isolate Wuhan. ठीक है, देखिए वुहान लिखा हुआ है, मतलब वुहान से जो वायरस आया था उसका ही जो है डेटा है पूरा. ठीक है, मतलब आपका जो वैक्सीन है वो वुहान का जो वायरस है उसी के बेस पे है, ओमिक्रॉन का बेस पे नहीं है. इसलिए ओमिक्रॉन जब आता है ये वैक्सीन आपका काम नहीं करेगा, क्योंकि आपका जो वैक्सीन जो है वो किसके अगेंस्ट में है, वुहान वेराइटी के अगेंस्ट में, ना कि सिंगापुर वेराइटी, डेल्टा, अल्फा, नथिंग, no Omicron, nothing, only the hardcore COVID virus. So this is the COVID genome. And from that genome, last time हमने BRCA प्रोग्राम को निकाला था, ये पूरा से हमने अभी ग्लाइकोप्रोटीन प्रोग्राम को निकाला है. ग्लाइकोप्रोटीन मतलब क्या, वो जो क्या है आपका जो है the spike protein जो है. So we will be using one more program which is based on support vector machine. We shall see how it runs. We have sent you the links also. So this is the whole, so many things. We will not use much detail of this. Okay. Now this is the this thing, the vaccine. Okay. One vaccine is highly unstable, but it looks similar. This is nothing but the structure of that, the spike protein. Okay. So we'll do a little hands-on to understand which is more stable, which is less stable. Okay. So we have taken 2 COVID spike protein data. Spike protein is very, very stable, which is very good vaccine, and one more similar structure only but unstable. So we shall see on which basis we are telling that one is stable and another is unstable. So you can understand computer science how it is helping to develop a vaccine within 1 year. किसी भी वैक्सीन को डेवलप करने में कम से कम 10 साल लगता है. तो कोविड का जो है वो हमने 1 साल में बना लिया. क्यों? We have deployed full scale computer science. ठीक है, जितना वेट लैब किया उससे ज्यादा जो है एनिमल के अंदर टेस्टिंग किया, ये किया, वो किया, लेकिन सबसे पहले क्या किया, कंप्यूटर सिमुलेशन किया. So you will see how exactly this thing works. So this also uses this what you call decision tree algorithm. This is an example how decision tree algorithm can help us. These are different aspects to it. This is the patent we submitted in 2020, and it also is around to detect mutations in genome sequences, and we have collaborated with this company, 2 companies in fact, this one and this one, to monetize or to market this product once the grant is completely given to us for a period of 8 years or so. So it may be a small scale thing, but we are anticipating to get a good amount of funding. So we have also submitted our study to IIT Mumbai. So they have given a first round approval, and we are anticipating that in couple of other rounds also we will able to get some amount of funding for this particular study. So now we will have a little hands-on. So I am unsharing my screen, and now I will request our coordinator again to share his desktop where he have downloaded the what we call is software Rasmol. I think it is already there in the desktop. So coordinator, please share your screen I think you have downloaded the software already. Yes, fine. So here what happens, I'll request you to share the whole screen, not a small window, because small screen होने से क्या होगा, ये पूरा अच्छे से समझ में नहीं आएगा. पूरा जो है आपका जो है, नहीं ये नहीं, आप जो है आपका पूरा स्क्रीन जो है कंप्यूटर का, डेस्कटॉप का, उसका आप शेयर कर लीजिए. एक विंडो को शेयर मत कीजिए, इसको क्लोज कर लीजिए. पूरा जो है आपका इसको एकदम शेयर कर दीजिए. तो क्या होगा, ये ठीक से दिखेगा. स्क्रीन नहीं दिख रहा है. हाँ, ये सबको आप क्लोज कर दीजिए. पूरा जो आपके पास जो पहले जो ये था, पूरा जो विंडोज सभी है उसको क्लोज कर दीजिए पूरा. हाँ, इसको क्लोज कर दीजिए. वो बैंडविड्थ का भी प्रॉब्लम हो जाएगा. ये क्लोज कर दीजिए सब कुछ, और सिंपल आपका डेस्कटॉप रखिए. सब कुछ क्लोज कर दीजिए.
ओके.
हाँ, सब कुछ उसको सब मिनिमाइज मिनिमाइज कर दीजिए. हाँ, अभी जो है इसको भी, ये जो है आपका मतलब कमांड प्रॉम्प्ट है. हम कमांड प्रॉम्प्ट यूज नहीं करेंगे, हम GUI को, ग्राफिकल यूजर इंटरफेस को प्रॉम्प्ट करेंगे. हाँ, इसमें आप डबल क्लिक कीजिए रासुइन में. हाँ, डबल क्लिक कर दीजिए तो विंडो ओपन हो जाएगा. हाँ, इसको छोटा ही रहने दीजिए, उसको बड़ा मत कीजिए. हाँ, इसको एक साइड में लगा लीजिए. हम क्या करेंगे, 2 सिमुलेशन करेंगे साइड बाय साइड. इसको एक कॉर्नर पे लगा दीजिए. हाँ, किसी भी साइड, राइट साइड और लेफ्ट साइड आप रख दीजिए. हाँ हाँ, उसको, हाँ अभी क्या कीजिए, ऑपोजिट साइड में कर दीजिए ताकि आपका आइकॉन जो है और एक बार दिखे. वो आइकॉन में आप दोबारा क्लिक कीजिए तो और एक विंडो खुल जाएगा. तो पूरा कंप्यूटर में 2 विंडो खुलेगा. हम हैंड इन हैंड 2 सिमुलेशन एक साथ करेंगे. हमने आपको 2 डाटा फाइल भेजा है. हाँ, अभी बहुत बढ़िया. फाइन. सो यू हैव आल्सो आई थिंक डाउनलोडेड द डाटा फाइल्स इन द डेस्कटॉप इटसेल्फ.
यस सर, यस.
डेस्कटॉप में है आपका डेटा फाइल जो हमने शेयर किया. बहुत बढ़िया. अभी आप क्या कीजिए, फाइल में चले जाइए, किसी भी एक विंडो में. किसी भी एक विंडो में फाइल में चले जाइए. ये जो प्रोग्राम है एक 25 MB प्रोग्राम है. इसको बोलते हैं मॉलिक्यूलर सिमुलेशन टूल बॉक्स. इससे जो है हम क्या कर सकते हैं, कोई भी वायरस का स्ट्रक्चर का जो है स्टेबिलिटी को एनालाइज कर सकते हैं. प्रोग्राम पाइथन में लिखा गया है और C++ में फ्री ऑफ कॉस्ट है. कोई भी डाउनलोड कर सकता है, किसी भी तरह से यूज कर सकता है. सो ओपन सोर्स है, कोई दिक्कत नहीं है. ओनली 25 MB. हाँ, अभी जो क्या है, आप फर्स्ट वाला जो डेटा फाइल है उसको सिलेक्ट कर लीजिए, ओपन कर लीजिए. हाँ, सिमिलरली दूसरा वाला विंडो में दूसरा वाला को ओपन कर लीजिए. हाँ, ये जो है आपका जो है स्केलेटन, ये जो कुल का 2 डायमेंशनल स्ट्रक्चर है, अभी उसको 3 डायमेंशनल कर लेंगे. ओके. सो दीज आर नथिंग बट द स्पाइक प्रोटीन ऑफ कोविड, and this is the shall we say 2-dimensional structural data, okay, of the COVID virus spike protein. Okay, so many spike protein, we have taken 2 spike protein. One is good for a vaccine, one is not good for a vaccine. So we will decide on the basis of the data science which is good and which is bad. ठीक है, अभी आप देखेंगे वो कैसे हम ये प्रेडिक्ट करते हैं. चलिए, अभी हम क्या करेंगे, ये 2 डायमेंशनल डेटा है उसको हम 3 डायमेंशनल मॉलिक्यूलर सरफेस में कन्वर्ट करेंगे. ठीक है, एक 3 डायमेंशनल स्ट्रक्चर. ठीक है. सो विल गो टू डिस्प्ले विंडो. देखिए उसमें डिस्प्ले बोल के है, ऊपर में देखिए डिस्प्ले बोल के है, वो डिस्प्ले में चले जाइए. हाँ, क्लिक कीजिए, एक ड्रॉप डाउन मेनू आएगा. डिस्प्ले में क्लिक कीजिए, एक ड्रॉप डाउन मेनू आएगा. देखिए, हाँ, ये जो आ गया लास्ट में देखिए मॉलिक्यूलर सरफेस बोल के है. मॉलिक्यूल कुछ भी और मत कीजिए, इसी को सिर्फ दबा दीजिए, मॉलिक्यूलर सरफेस को दबा दीजिए. हाँ, ये जो है आपका वो पूरा 3 डायमेंशनल में कन्वर्ट कर देगा इसको, पूरा डेटा को. हाँ, उसमें सेम तरह यहाँ पे भी कर लीजिए. छोड़ दीजिए, इसको छोड़ दीजिए, दूसरा वाला विंडो पे चाहिए, यहाँ पे भी सेम कर लीजिए. डिस्प्ले कीजिए, मॉलिक्यूलर सरफेस कीजिए. ओके. नाउ वी आर हैविंग 2 spike protein 3-dimensional structure. Okay. And each and every atom present on the molecule. Molecule क्या है, एक bigger entity है, उसमें क्या रहता है, बहुत सारा एटम रहता है, हाइड्रोजन, कार्बन, नाइट्रोजन, so many multiple different things. ठीक है. अभी क्या करेंगे, एक एक एटम का जो है उसका डेल्टा जी एस्टिमेट करेंगे. अकॉर्डिंग टू थर्मोडायनेमिक्स डेल्टा जी इज नथिंग बट फ्री एनर्जी. उसका यूनिट जो है किलो जूल्स पर मोल पे है. ठीक है, जैसे कि टेम्परेचर हो गया डिग्री सेंटीग्रेड, ऐसा नहीं है, जैसे कि क्या बोलते हैं इसको, आपका डेटा का साइज हो गया, टीबी हो गया, जीबी हो गया, इस तरह से डेल्टा जी जो है और फ्री एनर्जी जो है उसका जो यूनिट है उसको बोलते हैं किलो जूल्स पर मोल। ठीक है, ये थोड़ा क्वांटम मैकेनिक्स का कॉन्सेप्ट हो गया, फिर भी कंप्यूटर साइंस पीपल शुड अंडरस्टैंड। सो व्हाट हैपेंस, ईच एंड एवरी एटॉम इज हैविंग ए व्हाट फ्री एनर्जी entity or amount. Okay, so we have instructed the program in such a way, कोई भी एटॉम का डेल्टा जी कंटेंट अगर 0 से कम होता है, मतलब क्या नेगेटिव मैग्नीट्यूड में होता है, तो उसको आप कुछ भी कलर में कलर कीजिए। लेकिन किसी भी एटॉम का डेल्टा जी कंटेंट अगर 0 से ऊपर होता है, मतलब क्या पॉजिटिव होता है, तो उसको आप ब्लू कलर में कलर कीजिए। हमने क्या बोला, हमने ये प्रोग्राम को इंस्ट्रक्शन ऐसा कर दिया है, तो क्या कीजिएगा, वो इट विल डिसाइड, it will quantify at first what is the delta G content of each and every atom, hydrogen, proton, and then what phosphorus, nitrogen, each and every जो भी है, क्योंकि कोविड का जो प्रोटीन है, जो क्या बोलते हैं इसको, स्पाइक प्रोटीन है, इट इज मेड अप ऑफ व्हाट, n नंबर ऑफ कार्बन, n नंबर ऑफ नाइट्रोजन, ईच एंड एवरीथिंग। ठीक है, सो हमने क्या किया, प्रोग्राम को बता दिया है, whenever the delta G is more than 0 kilojoules per mole, you color it with blue color. Whenever it is less than 0, that is minus, you can put whatever color you want. But there are some instructions. ठीक है, so now what we'll do is we will estimate the delta G content of each and every atom. So it will take huge amount of time, isn't it? कार्बन का आप केमिस्ट्री बुक पे जाइएगा, देखिएगा कि कार्बन का डेल्टा जी कंटेंट क्या है, तो ईच एंड एवरी एटॉम को आपको जो है वो पीरियोडिक टेबल को निकालना पड़ेगा, फिर कैलकुलेट करना पड़ेगा, फिर कलर करना पड़ेगा। यहाँ पे हमने क्या किया है, वी विल डू इट इंस्टेंटली। सो वी विल गो टू वन मोर विंडो, देखिए कलर बोल के है एक ऑप्शन, देखिए ऊपर जो मेनू है आपका कलर ऑप्शन है, कलर पे जाइए, क्लिक कीजिए, ड्रॉप डाउन मेनू निकलेगा। ये मेनू में लास्ट में देखिए टेम्परेचर बोल के है, मिडिल में देखिए टेम्परेचर बोल के एक ऑप्शन, हाँ इसको आप क्लिक कर दीजिए। ये अभी जो क्लिक कर दिया, अभी क्या हुआ, इंस्ट्रक्शन ये हुआ कि कोई भी एटॉम उसका अगर डेल्टा जी कंटेंट लेस देन 0 है, मतलब माइनस है, तो ऑन द बेसिस ऑफ द मैग्नीट्यूड यू कलर इट। सो ये कलर हो गया, देखिए बहुत सारा डिफरेंट कलर, मतलब किसी का डेल्टा जी -10 है तो किसी का -1 है, जिसका भी जो है ऑन द बेसिस ऑफ दैट अकॉर्डिंग टू द इंस्ट्रक्शन गिवन इन द सॉफ्टवेयर or the program, it will color it. Okay, now we'll go to the next window, we'll do the same, we'll again color each and every atom on the basis of the delta G content. Okay, now we should understand what exactly is delta G. Achha, according to thermodynamics principle, it's a quantum mechanics concept, it says that whenever in any atom delta G is negative, it means it is more stable. बहुत ही सिंपल है आइडिया। कोई एटॉम में अगर बहुत ज्यादा एनर्जी है, क्या करेगा, वो कंटिन्यूअसली मतलब क्या करेगा, वाइब्रेट करता रहेगा। ओके, रेजोनेंस similar for example, my kid is very energetic, so what she does, she continuously moves around, she doesn't sit anywhere like this. Okay, so why, because this the inherent energy is bit more. Similarly here also, if the atom is having more energy, so what it will do, it will become unstable. Whenever it will enter into the blood, it will disintegrate instantly. So it is good to have less energy in certain points, isn't it? So similarly here, we have understood that there are two different epitopes or two different glycoproteins. One is highly unstable, देखिए blue color, क्योंकि delta G content जो है बहुत ज्यादा है, positive magnitude. So whenever it will inject, you will inject this particular proton molecule into the blood, it will undergo disintegration, और आपको every महीने you have to go and take a vaccine, that is a booster dose. But on the right hand side, a colorful protein is there where the delta G is different at different point. At least it is not very much blue. What does it mean? It means that it is comparatively more stable, and therefore this could be a better vaccine. So I'm giving you a small idea, but multiple different aspects are also there. But this energetic understanding is also very important for vaccine design. So today you can see, you can Google it everywhere. Any vaccine takes at least 10 years to develop. So this vaccine was developed However, it was this thing of debate, how good or bad it is, but it was there and it saved people because computer science was there. So this is how I would like to conclude the session. I do not know whether you have found any value in it. I sincerely hope that it will give you some idea that how exactly biomedical fraternity is using computer science to a significant extent. Okay. So this was all thing that I wanted to share with you. If there are some queries, I can also try to answer. Okay, and again, thank you for the coordinator for your
thank you, Dr. Saab. Thank you. Very informative
giving
session,
me an
sir.
opportunity.
Thank you very much to accept the invitation from my side. Okay, I hope that all the participants get benefited by our talk. Nazmun sir.
Yeah, if there's any query, please ask. Dear participant, if there's any query, please ask.
Yes, yes.
Sir, is this tool Rasmol, is this open source or is
yes,
this open
yes.
source for any?
You please yes, you can download it if you are interested for three-dimensional structural
Studies for biomedicine. There are plenty of use, I'll say. For example, I give you one more idea. There is a algorithm called boiled egg algorithm. उसमें जो है you can predict that which kind of animal protein is good for bodybuilders, or how long you should boil your egg, how long you should boil your milk before this thing, isn't it? And multiple different aspects to it. We are using it for this particular thing.
Sir, it works same for
Yes,
that
yes.
as well. I mean, we are calculating it on the basis of score of delta and coloring it in this software. Is that so?
Yes, yes. Yes, yes, yes. Definitely, definitely.
Thank you, sir. Thank you very much.
Yes, yes, yes.
Anybody else
So
from the
computer
participants
science
want to
is
ask
giving
any
a
question?
very good this thing. If some of you are interested for some kind of collaboration, if you want, you can definitely through the coordinator. He is having my email ID as well as WhatsApp number also. We can definitely get in touch
Definitely,
and
Dr. Saab,
discuss
definitely.
in brief what exactly we are trying to do now. Yes, yes.
Please share the WhatsApp number on the chat box.
Yes, sure, sure. Yes, yes. I'm finding it. Yes.
Thank you
The
so much, sir.
This is the email ID. It is the WhatsApp and the phone number is this. Yes.
Yes. I'm also thankful, and I should thank the coordinator sir also for doing this excellent session, for calling so many people there in
Thank
the
you, sir.
midst
Thank
of difficult times we all are going through. Thank you, Gulfam sir.
Thank you, sir, to accept the invitation and share the informative session. I hope that all the participants get benefited by this, and especially for the biosciences and computer sciences, participants maybe get benefited more and more. And inshallah, we will keep in touch, sir. We want a collaboration with you. Some of scholars are working on the research in the biosciences, such as corona also. So maybe it is possible we and you may work together with an MOUs. Okay, sir.
Sure. That is right. That is right. If we do a formal MOU, it will be beneficial for both. Yes, it's absolutely right. We will definitely have a detailed discussion.
Okay, sir.
Zarur, sir. Sahi hai, sir.
Yeah, Najma, please conclude.
Thank you so much, sir. Thank you for this wonderful session. Dear participants, here the today's session ends. Hopefully, we will meet tomorrow at the same time. Till then, take care and Allah Hafiz.
Participant, I am sharing the live streaming of our FDP on YouTube. You can see the lecture at YouTube at any time. Okay.
So do you have any portal, any websites of your where your content and data is there, so that we will study and we will contact you later on?
Shortly, we will share the link of the YouTube.
Okay.
क्या मांग रहे हैं?